of the Dev Summit this year. One thing I did want to do before we get started with our program, a lot of today's sessions are going to be pretty interactive. And so somebody, probably myself or Ed, will be running around with a microphone. But when you have the handheld mic, we do ask that you really try to speak into the mic. In general, my understanding is microphones like this are pretty directional. So if you hold it down here, no one can hear you. Or if you start talking to the side, no one can hear you. So really try to, like, it's not quite ice cream. It's not quite an ice cream cone, but it's almost an ice cream cone. So like, put it where you'd put an ice cream cone. Something like that. Don't lick it, please. This makes it harder anyway. But do try to like eat the mic a little bit. Okay, so our first session this morning is going to focus on release engineering, and it's going to be chaired by Colin. So I'm going to hand it over to Colin, and we'll all have a lot of fun.
All right, thank you. So yes, I am here at 6 a.m. Vancouver time, so if I seem a bit sleepy, that's why. It's not that I'm really bored with release engineering. So just an overview of what I'll be talking about here. First, to introduce myself, the FreeBSD people here hopefully know who I am. There may be some guests, or especially people watching online who I haven't met before. So I'll talk about what my view of FreeBSD release engineering is, what I'm changing compared to how Glenn was doing things for a decade, things I've learned over the past year or so, and then the main part of this is really for discussing the plans for future release scheduling. So I've been a FreeBSD developer since 2004. I was security officer for almost 5 years, so I sort of know how that side of things works. I started working on FreeBSD in EC2 in 2010, and I've sort of been maintaining it since 2013. I got the code into the FreeBSD release building process around 2015, working with Glenn on that, and that was sort of my introduction to the FreeBSD release engineering system. I took over as deputy lead in 2020, and then I've been the release engineering lead since December of last year. I was release engineer for, well, 2 releases so far, and one that I'm going to be building later today. And just a note on terminology, because people tend to get things terminology confused here. When I refer to the release engineering lead, I mean the person who is the lead on the team, who is not always the release engineer for a particular release. So in particular, Mike has volunteered to be the release engineer for 13.4. He's the release engineering deputy lead, but this will make sure that he has practice doing release so that if I get hit by a bus, he knows what to do to take over. So what is FreeBSD release engineering? As I see it, it is basically the process of taking all of the stuff that you all do in the FreeBSD Git repositories and turning it into the stuff that users actually use. So the ISO images, the VM images, and all the stuff in the various clouds. EC2, Google, Azure, Vagrant we support. I don't know if anybody actually uses it, but we're still building it. The release engineering team is not defining the goals for the project for upcoming releases. We will say, no, we will not let you put that into the tree 2 weeks before the release. That is a huge bunch of new code, which is likely to break stuff. But we're not going to say, we think that in FreeBSD 15, we should have X, Y, and Z. John will be helping all of us decide that later today. John and Ed, I think, running that session. But ultimately, that is the FreeBSD developer community who decide what is going to be in the next release. I just take the work that you have done and turn it into a release. We are not the people writing FreeBSD. You are all the people writing FreeBSD. Release engineering is not about fixing bugs in the upcoming release. Now, when we start pushing out betas, people start reporting bugs to us, which it's what I want. I want to know when people find bugs and to know what issues you need to resolve. But if it gets to the point where I am digging into some random code that I've never worked with, trying to figure out what did somebody break here so that we can get the release out the door, something has gone wrong. The position I want to be in is somebody reports a bug to us, and I say, hey, Brooks, this is your code. Please fix it. Make sure it's working before the release. And it is sort of about handling errata. When we set up the whole idea of release errata notices versus security advisories back in, I think it was 2004. I remember a long conference call with Jacques and, was it Murray Stokely at the time, who was release engineer, where we sort of planned out the whole idea of errata notices as an addition to the security advisories we were already doing. We said, oh, well, release engineering will deal with errata notices, and then they'll put together the patch, they'll write the errata notice, they'll just ship it over to the security team to put out with with advisories that are being put out at the same time. It all has to go through the security officer team because they do FreeBSD update builds, which makes the bits available to users who want binary updates, and the security team has to approve stuff going into the tree because we don't want to have release engineering and security teams pushing stuff in at the same time and getting in each other's way. So that was the idea. In practice, the security officer team does basically all the work for release for errata notices now. Often, developers email the security team anyway, and the release engineering team doesn't even know that there's an errata notice coming until we see it announced. So theoretically, release engineering is involved with errata notices, but in practice, it's the security officer team that does most of the work there. So what am I changing compared to the way that things have been done, well, for the past decade under Glenn and previous decade under various other release engineers? I want to do more frequent minor releases. We have talked a lot in the past at developer summits about how often should you do minor releases, and then reality has sort of ended up being somewhat slower than what we have aimed for. I've heard people say every 6 months, and then it's ended up being every 9 months or every year. I want to have a schedule and be doing them frequently. I am aiming to streamline the release cycle. For many, many years, I didn't look back at the historical schedules on the website, but we've tended to publish a schedule that says we're going to have 3 betas, and then we're going to have 3 release candidates, and then we're going to have a release. Well, if we have release candidate 1, if it's a release candidate, it should be something that we think is a candidate to be a release, sort of what the words mean. So as I see it, we should only be aiming to have 1 release candidate. And yeah, if things go wrong, then fine, we fix things and we have a second release candidate. But my goal is we will have 1 release candidate, and then we will have the release. So by RC1, we should have everything fixed. And not going to be letting in people bring in a whole bunch of new code at beta 3 and just sort of hope, well, maybe there won't be any bugs. So I'm going to be stricter than past release engineers have about not letting code in and aiming. So for 13.3 and 14.1, I went with past practice and I put 3 release candidates on the schedule. In both cases, we're only having 1 release candidate. We're going to release, unless something lands in my inbox today, we're going to do the release tomorrow. And no, the release will not wait for your important new feature. Now, when it comes to a .0 release, there may be things like, we could not do FreeBSD 14.0 without OpenSSL 3 in the tree. So with major releases, .0s, we need to talk about what do we really need to have in the tree, and then we need to make sure those things land in time to be in the release. But if it's stuff that we haven't discussed here, or somewhere else, but a major discussion in the project about what we really, really need to have in a .0 release, no, I'm not going to hold things up for some new feature that you want to have. And that applies to me as well. I have several things that would have landed in 14.1 if I wasn't busy doing the 14.1 release. But I'll get those into 14.2, hopefully. And yeah, if your recently added code is broken, I will be asking you to back it out. There have been a few times recently where code came in just before beta 1, and then it was broken. And I said, OK, if you can get it fixed in the next week, if it is completely working in beta 2, that's fine. But if we merge patches for beta 2 and then there's still any problems, I'm not going to give you 3 or 4 chances to try to iterate on this to get it working. It's going to come out. Fortunately, it's worked out so far, but I haven't had to ask anybody to back things out, except there was one thing in 13.2 that was, yeah, I don't want to speculate what it was, but there was one thing that went in that I asked to have backed out because there were a whole series of patches coming onto that one. But yes, I will ask for things to be backed out if they just seem to be not ready, or if I'm concerned that they might not be ready. But of course, if we're having more frequent releases, then it's no longer a matter of I really need to get this into this release because otherwise I need to wait a year for it to be in the next release. You will be waiting 6 months probably for the next release. So it is less of a concern in that sense. I want to know about issues affecting upcoming releases as early as possible. So I don't want to get an email saying, today, hey, there's this critical bug fix. Please, can I merge it into Relang 14.1? If that is the first time I hear about an issue, something has gone drastically wrong. I don't want to hear about an issue when you merge it into stable 14. I don't want to hear about an issue when you commit it to head. I want to hear about an issue when it is first reported to you. Somebody sends you an email saying, hey, this is broken, or you notice something is broken. Send me an email at that point saying, hey, there's something broken here. I have not investigated it yet. I don't know where the bug is in the code. I don't know how to fix it yet, but there is an issue. Because I will put that onto my agenda of this is something that needs to be fixed for the release, or it might go into the not critical enough to hold up the release for, but I want to know that there is an issue because that way I can track it. I can send you an email the next week saying, hey, what's the status of this? Do you think you're going to have it ready for the next beta, or for release candidate 1? Is this something that I need to worry about holding up the release for? So yes, please let me know about issues as soon as you are aware of something. And this goes both ways. I want to be more transparent as a release engineer about the status of things. So there's now, for 13.3 and 14.1, there's a wiki page which tracks all of the issues that we are aware of. And if you look at the history of that page, you will see there's a bunch of issues that suddenly show up as merge approved to Relang branch that do not show up in any of the earlier categories, which is where things have gone wrong in the past. But yes, I will do my best to be more transparent about the current state of the tree, what we need to get into the release, and the process about where things are going, and sending out more emails. A few times in the past 6 months, people have said, hey, it would be nice to get an email on this list, say FreeBSD stable, announcing schedule, or whatever. Send an email to developers letting us know that where we are and that we're going to have beta 3 coming later today. So every time people have sent me emails saying that or mentioned it on IRC, I've been putting it into my schedule of things that need to happen in the release cycle. And there will be more emails. And if there's anybody that you think should get an email that is not getting an email at a certain point in the release, let us know, and I am happy to send out as many emails as people want. Hopefully not too many. So what have I learned about release engineering so far? Well, it takes about 2 months to do a minor release, if everything goes well. There's about 2 weeks where I send out an email saying, code slush is coming soon. If you have major stuff you want to get into the tree, please do it now in the next 2 months, in the next 2 weeks, because once we go into code slush, I do not want to see huge dumps of new code. Then we have 2 weeks of code slush, where the tree is still open, but I say, please focus on fixing the bugs that are already there rather than introducing new bugs. I mean, introducing new features. Then we start. Then I fork the Relang branch at that point, and then we start doing beta builds, beta 1, beta 2, beta 3, RC1. they're all a week apart. I do the builds at midnight UTC on Friday mornings, which is for me Thursday afternoons. And then usually it sort of takes the weekend to do the builds, sometimes redo the builds if something breaks in the build process, send the bits over to the security team so they can get all the FreeBSD update bits in place, and then Sunday or Monday or so, everything's ready for me to send out the announcement saying, here we go, the bits are available on the FTP servers, download servers, everything's available in the clouds. Please go test and let us know what bugs you find. And then 3 or 4 days for people to find issues before we start doing the next builds. So yeah, this schedule of sort of doing one build every week works fairly well. We can't really compress it just because of the timelines for building things and getting people to test. And I mean, it would be nice if we could just have beta 1 and then RC1 and then release, but realistically, I don't think we can do it with less than 3 betas. While we are doing this, while I'm doing the builds, other things are happening with other people in the project. Mike does a great job of writing all the release notes, but he can't really start putting together the release notes until we have a branch. So we branch beta 1, and then he starts going through the Git history and please mark things in your Git commits as rel notes yes, or rel notes this is the text I want to have in the release notes, because it makes his job a lot easier. But even if everybody tags things that need to go into there, it takes a while for Mike to put together the release notes. The doc tree needs to be tagged, and it needs to be tagged early enough that we can then have packages built which include that doc tree, because the doc tree is then tagged and turned into a package in the ports tree. And the ARM packages take like 2 weeks before we get a full package set. Once all packages are ready, then I tag the ports tree. I get the cluster admin team to copy that package set to be the package set for the release. So all of these other things that are happening, there's also sort of a 3 or 4 week minimum between when we branch, relling, whatever, and when we can do the release. And I want to have a package set for RC1 because we might not have any more release candidates, and we want to know, can somebody download the DVD image and go ahead and install install Xorg or Wayland or whatever they want from the DVD. Major releases take longer. So just as a matter of what the schedule looks like, for major releases, we don't just have beta and then release candidate. We have alpha and then beta and then release candidate. Things that we call alpha are builds that happen from current. Things that we call beta are builds after we've branched the relling branch. So typically we have 3, sometimes more alphas. So that's sort of, we have about a month of alphas images going out before everything that happens in the minor releases happens. So that is at least 3 months, and typically with major releases, there are more bugs that need to be fixed, and so we're not just going to manage with 3 betas, it's going to end up being more of them. And then finally, we need some time between releases just to debug and improve the release building process. I have a number of issues on my plate, with things like parallel release building breaks on stable 14. Oddly enough, it works fine on current, but I actually backed that code out of relling 14.1 because the releases were breaking. I was getting weird errors where install couldn't find files that were there when I looked for them. Something to do with doing multiple install worlds into different places at the same time. So once the release is done, I will be figuring out what was broken there and fixing that. But we can't really debug problems with the release building process at the same time as we're doing releases. Theoretically, you'd think, well, if we're debugging the issues in the stable branch, that doesn't affect the relling branch. But just in terms of bandwidth, we can't do both of them at the same time. So I want to sort of allow a month-ish for cleaning up stuff in the Velang system between the actual scheduled release cycles. What else have I learned? It takes about 100 hours of my work to do a minor release. This is very much not spread out through the time period. I would say the week leading up to RC1, I was pretty much working full time on getting everything in, which meant looking at patches and improving them, making sure that we had the packages in place, doing all of the sort of standard commits of, now that we're at RC1, we need to get the packages from over here, and chasing people saying, hey, I heard a while ago that there was this issue. I haven't heard recently. What's going on? This 100 hours of work, if we had fantastic communication from all the developers, where you let me know as soon as you're aware of an issue, and every time it develops, so when you know what's going on, you've got a patch, you've committed it to head, you've committed it to stable. If you sent me an email every time one of those happened, I would not need to be chasing you as much, and that 100 hours of work might be 60 hours of work instead. So please make my life easier. Please give me less work. But aside from that, yes, it is very unevenly distributed. It really piles up just before RC1. At the beginning of the release cycle, it's a couple hours just to do a beta 1 build. Doesn't take very long. But as I'm tracking more issues and trying, pushing people to make sure that things get fixed, it gets very busy at the end. I do not want to make this mistake of being on the organizing committee of the conference and agreeing to do 2 talks and delivering a FreeBSD release all in the same week. Thank you to my wife, who has been very patient with me, but that is too much to do in 1 week. More frequent minor releases will make things easier, not harder. When we were doing a minor release every 9 months or every 12 months, there would be more stuff accumulated in the tree, more stuff that was broken, and so we would need more time to get everything sorted out before the release. And conversely, because it was longer between releases, people were more desperate to get their code in. People would commit things that weren't as ready because they said, I haven't fully debugged this, but I really need to get it in because I don't want to wait another year. So hopefully, more frequent minor releases will make everything easier for release engineering as well as the rest of the community. So scheduling of future releases. Practically speaking, we can't do a minor release more than once every 3 months. We've got 2 months of release cycle, and we need a month in between releases to sort of get things in order with the release engineering process for builds. Theoretically, we could do releases from different stable branches in parallel. It has happened in the past. But I think that was like a 0.2 and a 0.4 release happening at the same time, which, the later you are in a stable branch, the easier things get, because there's less stuff that's broken generally. And the comment from Glenn that I got was, yeah, we never want to do that again. It is a lot of work, especially if anything starts going wrong. And unless somebody wants to throw a lot of money at me and say, please work on this full time, no, it's just not happening. So 3 months per minor release, and they're not happening at the same time. For a major release, we really need to allow 6 months. 4 months of release cycle, and then we want to have a bit of slack because stuff is more likely to break for major releases and delay things. Now, we can't schedule when the release is going to happen. Some projects do that. I'm not going to go that direction of just saying, it looks like it's time, tag the tree. If stuff is broken, I will hold the release until we can get things fixed or backed out if they can't be fixed. But we can't schedule when the release cycle starts. So I can say, in February 1st, say we're going to start the slush, and then everything sort of schedules on from there, and that would end up with the release sometime around middle of March. What I noticed with 14.0 is having BSDCan happen as we're starting to plan a 0.0 release is really useful for making sure that all the bits land in time. We had a lot of discussion last year about what's going on with OpenSSL 3. Is everything ready for that? I think there were some LLVM bits that needed to land as well. If we're trying to, if we're thinking where should BSDCan happen in relation to the release, I would prefer to have a large developer summit before we start the release cycle, so that we can discuss what are these things that really need to get into the release that we want to make sure they're done so they're not holding up the release. As I say, minor releases are not going to hold the release for your new feature. Major releases, sometimes there's stuff that really does need to go into that 0.0 release that we will need to hold up the release if it's not ready. We could not do 14. If OpenSSL 3 was not in the tree, we were not going to do 14.0. In fact, 14.0 I think was originally scheduled for July, maybe August, and then because OpenSSL was not ready, or we were not ready with OpenSSL, it got pushed back several months to land in November instead. So here's a model of how things could look like. One release per quarter. I say quarters. It's a convenient way of looking at the calendar. Think every 3 months. Generally speaking, we're looking at the release cycle starting towards the beginning of the quarter and the release happening towards the end of the quarter, but pretty much within that quarter. I would like to have one release per quarter, because we can do that for minor releases. And then for major releases, we need 2 quarters, 6 months. And as I say, having the major release cycle start soon after BSDCan worked pretty well with 14.0. No guarantees, but I think that will work well. So I would start those in Q3 and then have the 0.0 release happen in Q4. Generally speaking, there's no point doing 14.1 followed by 14.2 3 months later and neglecting 13.x. So I would alternate between the most recent and the previous stable branch in terms of the quarterly releases. This gives us a schedule where you've got usually 6 months between releases in the major branch. So 14.1 is happening right now. 14.2 will happen in November or so, November, December. 14.3 will happen this time next year. If there's a major branch in between, a major release in between, then that pushes things back because we've got an extra quarter of doing that release. So then you've got 9 months between 14.3 and 14.4. Now, the one problem with this schedule is 14.6 in this schedule will be the final 14.x release. You see, it's happening in Q1 of 2027. So that's 3 years and 3 months after 14.0. Right now, we say we've got major branches for 5 years. We announced that we support the stable branch for 5 years. So this means that the final release from that branch would be supported for 21 months. I don't know if we want to do that. From my experience on security officer team, that's kind of pushing it for how long we would want to support a minor release. So then we look at, well, if we don't want to do that, how do we resolve this? So one option is we do an extra 14.x release after 16.0 is released. So we would add a 14.7 release happening sometime in 2028. Then we've got only 9 months that's being supported before the end of life of 14.x. But then that pushes everything back. So then instead of having a minor release every 6 months, we've mostly got minor releases every 9 months. The other option is to say, do we actually need to support major branches for 5 years? If we cut that down to 4 years, then it makes our life a lot easier. It lines up with the schedule of a major release every 2 years. Then we've got a major release every 2 years. They're supported for 4 years. So at any point in time, we are always supporting 2 stable branches. We just alternate between the most recent stable and the previous stable. Everything's easy to plan, but it does mean that we're cutting back from 5 years to 4 years. So those are the 2 options that I've come up with in terms of scheduling. Upsides and downsides to both, but I want to hear feedback. And you have the mic, and I see a question up there. And I'm just going to go back to this page, and if you want to look at the other schedule, just let me know.
With regards to the minor releases, is there anything not allowed to go in? So any major changes to certain components or whatever else?
Right, okay, so for minor releases, because we're talking about releases on a stable branch, we do not want to have things that break API. Now, occasionally it does happen, particularly with video code. We've had issues, but the goal is to avoid things breaking, because theoretically you should be able to build packages for the .0 release and use them for the rest of that branch. And in fact, the package building, we have a package set for a stable branch, and they are built on the oldest currently supported release of that stable branch. So the packages for 14.1 are built on 14.0 release. So if you break stuff significantly on a stable branch, then people who are just downloading packages will find they don't work, which is not the experience we want them to have. So yes, certain things we cannot merge into a stable branch because they break compatibility like that.
I do think, though, it's true that we don't, for example, have a moratorium on adding new features in a stable branch.
Yeah,
So
new features are fine as long as they don't break compatibility. Yes.
So I think we're pretty liberal in what we actually permit merging relative to perhaps other entities.
I will not comment on other
practice.
operating systems. Warner has a question. Oh, Doug has a question. Okay.
I just like watching.
You just want Don to get some exercise. Okay.
Well, my phone's not on me, so it's not counting these.
I'm extra cruel.
Yeah, so my question is about patch releases rather than minor releases. Right now, if I'm installing FreeBSD, especially a relatively late in the cycle on that branch, I install the release, and then I install hundreds of patches on top. Why don't we publish installers for patch releases? What's blocking?
Why don't we publish? So there's a couple issues there. The first one is we signed the release announcement with the hashes of the ISOs.
Right.
So if we roll new ISOs with patched code, then either people don't know that they're getting the right one, or we need to re-sign everything. Makes life a bit difficult.
I'm not suggesting that we replace the original ISO, but have
additional ones.
A P1, a P2.
Right. Another issue is space on the FTP servers.
Yeah.
I think cluster admin will be very annoyed with me if I start giving them like 15 different DVD images for each platform for each release. They might be okay with me saying there's the original release and then have the most recent one.
Yeah. I think that would be helpful, especially if you're installing. You want to be like secure from.
Yeah. So that is an option. Another issue is we have FreeBSD update providing people with binary updates.
Mm-hmm.
If we, I mean, It might be more or less okay now because we mostly have reproducible builds, but when we had less reproducible builds, if we just use the release building process to build new ISOs, they would have different bits than what FreeBSD Update was sending out. And FreeBSD Update would freak out because it would say, you have a version of bin ls, which is not the one that shipped with the release, and it's not one that I gave you. So where did it come from? Did you make some changes to to ls yourself? In the past, I have looked at could we sort of take the ISOs and pull out the bits that we install, use FreeBSD Update to update those, then package them back up and put them back into the ISOs. And that might work. Let's just say there's a lot of moving pieces and it's difficult, but it is something I would like to do. Probably the first place that I would try to do this would be in clouds, because with EC2, Amazon has lots of disk space. I can put up lots of new images there, and it's not a problem. And there, it is particularly an issue of people do not want to have their newly spun up FreeBSD release spend 10 minutes downloading patches, because with clouds you have auto scaling, and you want your new system to be immediately serving traffic. So I would probably do this with EC2 first, and it's on my to-do list, and then based on how that goes, look at expanding it to having an updated ISOs, maybe not the DVD images, because if you're downloading a DVD image 5 months after the release, the packages on there aren't much use to you anyway. But certainly for the disk one CD size image, I would probably move in that direction of having the release and then the most recent update to it. But yeah, it's on my list of things to look at, but it's not trivial.
Okay, thank you.
So related, I have a bug I didn't fully resolve, where someone wanted an EN for 14.0 because it was a fixed panic on boot that doesn't let you see your SATA disks, which an EN is useless if we don't spin a new installer.
Right.
Right. I mean, those are rare, but I did have one.
Yeah, and that's one of the few things that I will definitely hold up the release for, rather than saying, no, just do an errata notice afterwards. If you can't install, then yeah, I'm not going to say just wait for the errata notice. Yes, Alan.
Yeah. I definitely like the idea of the major releases being at the same time of year, like predictable, versus our current, even with the schedule technically was every 2.5 years, and so that meant it was never going to be at the same time any 2 releases in a row.
Yeah, I think actually we were aiming for every 2 years, but it ended up being every 2.5 years. Yes.
Well, I thought it was every 2.5 because of the 5 years support cycle. It was wonky.
Yeah.
But yeah, without shrinking the long-term support for the oldest one down, how does this not cause massive headaches for the ports team trying to keep software compiling on a 4.5-year-old release?
Well, I mean, currently we have massive headaches with 4.5-year-old releases. If it was up to me, I would say let's shrink it down to 4 years for many reasons. But that is something that I think we need the developer community to weigh in on, which is why we're having this conversation.
Yeah, I would say the only thing is if we're going to do that, we'd have to do it starting with new releases, not retroactively pulling the rug out on any old release.
Yes, I mean, we're not going to stop supporting 13.x or 14.x earlier than we announced, but that doesn't necessarily mean that we need to do a 14.7 release. We could just say 14.6 is the last one, and yeah, it's going to be supported for 21 months and live with it.
Another way of stating the question rather than age, and I'll do the mics in a second, is how many concurrent branches of support we can stomach. And I feel like that's the number that 3 stable branches concurrent is too many.
Yes,
and 3 total branches, including main, is probably the cap of what we can stomach as a
and historically we have usually had 3 branches, including main, and occasionally 4. Usually for like 3 months or so, where we get the .0 release out just before the EOL of the two releases previous.
Yes, there's one constraint that we didn't talk about, actually. It's the constraint that after some minor release, the previous one is going to be phased out 3 months after. So with the interleaving of two major releases getting minor releases, that means that for example, a minor release will leave for 6 months, and then you have 3 months to upgrade to the next one. So isn't it quite short for the project or for users, or does it mean that it will be better to interleave with three stable branches to have more time for each?
Yeah, so
minor release?
we've had this discussion a few times of if we have more frequent minor releases, are we forcing users to upgrade more frequently? And the answer is yes. I think most people would prefer to have the more frequent minor releases and tell users deal with it. One option would be to say if we're having minor releases every 6 months within a stable branch, maybe ports team can agree to support the previous minor release for 6 months instead of 3 months. If we're going from a minor release every year to a minor release every 6 months, then the total time that a particular minor release needs to be supported would still be shrinking from 15 months down to 12 months. So we can also talk about how long should we be supporting a minor release after the next one comes out on that branch. But 3 months or 6 months, either way. One thing I like about having a quarterly schedule is that it sort of lines up with other things in the project. If we say if it's a 3 months or 6 months for how long we support the previous release, then it's lining up with the quarters. It lines up with the quarterly branches for the ports tree as well. So I think just in terms of having a schedule that users can understand, having things line up nicely is helpful, I think.
Yeah, I guess I'm going to comment on the particular the major releases. Having a long tail, the biggest problem that I see for ports is that the compiler in the last release is going to be utterly obsolete.
Right.
You're going to be at the end of a 21 months. You're going to be running LLVM four major revisions old.
Right.
And sometimes that's fine, and sometimes that's completely untenable. You just basically start marking everything broken, and to hell with the branch because it's not worth it.
Right.
And there are other ways we could fix it. We could kick the compiler out of the base, and that would solve the problem. But and make it ports as problem instead. But that'd be very exciting, and not what I'm proposing.
Yeah, I mean, there have been times where a large part of the ports tree is marked as you need to use LLVM whatever from the ports tree instead of what's in the base, but that's not a great solution. I see 2 people up here. I'm not sure who was first. Warner, okay.
So I have 2 questions. One, this makes the kernel loadable modules problem way worse. So we need to prioritize fixing it because I like this schedule. But instead of 3 months of overlap every year, we have 6 months of overlap every year where we're building it on the wrong release. So either we need to get better about having a actually stable binary release for the kernel. And the Linux emulator is usually the worst offender there. Most of the other stuff, if you get the Linux emulator working, works. But it's still most, and there's still bumps. So we need to prioritize fixing that. Not making sure it's stable, but making sure that we can provide good binaries. And the other thing with this release cycle going from 5 years to 4 years, I think de facto, this is kind of echoes what Brooks was saying, de facto, we support it for about 3.5 years and then have kind of a increasingly crappy experience after that today. And so that's not really changing anything. That's just messaging to our users that we tried to shoot the moon and couldn't. 5 years just couldn't happen. We know you want it, but too bad.
Yeah, I would say that the security team has done a great job of supporting branches for 5 years, but it is harder for ports because of things like toolchain updates.
Right. You can have some important bug fixes, maybe as long as you don't have the wrong package installed towards the end of the 12 branch. But it was just quite difficult to have all the packages that you wanted and run 12 for the last year or so that we had the 12 branch. So I think I'd like to put in my 2 cents for making that 4 or maybe even 3 years. Sorry. Third thing. Usually right before the release, all the vendors show up at my door and want new drivers in the tree. Do we have a good mechanism for creating images that would have the new drivers if they arrive just a little bit too late and you don't want to wait 6 months for the new driver? So if we do go to building the latest patch release, that would solve that problem too, I guess. So.
I don't think there's any good mechanism for that unless you can convince sec team to push them out as an errata notice. I would say the solution to the vendor driver issue is if we have a schedule, they know when they need to get the new drivers in.
The vendors aren't going to care.
Actually, Intel has said that to us many times, that if they had a schedule, they would line it up.
Intel will care, but
Yeah, I've actually heard.
Well, they'll learn through beatings. Well, they'll learn that it kind of is, but
I'm going to go to the release. I'm going to try to do an RE with each of the drivers I need to do for people that are ready. It's supposed to be an easy, lightweight process, I'm told.
all right, you're being too ridiculous.
Yeah,
I do want to.
Sorry, if I could just say, I've also heard from Amazon that they would like to know what the release schedule is going to be so that they can line up the releases of their network driver with us. So it's not just Intel. But I agree some vendors may have issues and they may need to get beaten until the problem is solved.
For them to line the release schedule up for us. But we do matter enough that they want the latest driver.
I do want to. I want to echo well, let's see. You hit on something that I want to say, but I'm being the messenger, not that this is what I agree with. It's true that from the survey, our users, they mostly like frequent. They would like major releases really frequent. Like 2 years was the most common, but 1 year was the next most common, which is like not doable. They would like the branches to be supported for quite a long time, although actually most of them would be happy, I think, with 4 years. So I do think, and there's a constraint in how much as a volunteer project being done for free that we can do. The other thing that we've asked is that, was anybody willing to pay for longer support? And the overwhelming answer is no. So, I mean, we can't give them all the unicorns they want.
Right.
But. All right, who wants to go next? I think you're next, Andy.
So you said that you're pleased that BSDCan times well with the .0 release.
Yes.
Would the Bay Area Dev Summit or Vendor Summit, whichever way you want to look at it, would that tie in, or would that be do we shift that so that it can tie in?
So I have to admit here, I've actually never been to the Vendor Summit in the Bay Area. I probably should because it is closer to me in Vancouver than BSDCan is, but just in terms of scheduling, I just haven't been there. My impression is that there's a lot more vendors there and fewer developers. And I think in terms of saying what do we really need to have in the release, it's the developers and not the vendors who will be getting yelled at and saying, we really need you to get this code ready. But it might help. I don't know enough about what goes on at the Vendor Summit to really comment on that. Maybe John can comment on that.
Yeah, so you don't maybe know Andy. I wrote an email a few months ago where I had written down some thoughts about trying to have the project-wide be a bit more on a cyclical calendar. But it's an idea that several of us have kicked around in the past that I kind of put a stab in the road and said, we'll make BSDCan the kind of center of our calendar that we rotate around. only because historically this is the largest group of developers we have in a room anytime during the year, and that's been true at least for a decade of going back over different conferences. That this is when we have the largest gathering. So that's kind of why the thoughts we've been kicking around recently have been using that as our like reference point for like the start of a new year, like a fiscal year starter, if that makes sense. All right, someone else should talk.
I don't know if I go against the grain here. I am going against the grain with everything that was said, but it seems to me, Deb yesterday mentioned that we want more presence in the enterprise, like companies to adopt FreeBSD, but 4-year support for the enterprise. I know it's not true for Netflix, but for other enterprises, that seems really short. And I don't know if there's plans to have at least security updates, for longer releases sometimes.
If they want to pay for it, maybe. I think ultimately, if they're not paying for it, then this is a volunteer project, and there's a limit to what we can support.
Thanks. That was just a question.
Yeah. No, I agree that it is an issue for some enterprise customers, but we have constraints as a project. I don't know if there's a good solution to that, really.
Yeah, yes. It's a historical thing that there is that trade-off.
I see here, and I think Alan put his hand up.
You're not going to get my steps in?
Yeah, just to respond to that against the grain comment about support for enterprise, I think that's where the FreeBSD ecosystem can come in and help out. So people like Clara and others that are able to offer support can do so. As Colin said, it's a volunteer community. I come from other projects like the Octo project where it used to be 2 years our long-term support. It's extended to 4 years now. And if people want longer than 4 years, like automotive vendors, whatever else, there's a raft of different people that can offer that facility to them if they want to pay. If they don't want to pay, you get what you're given, you be grateful, and we'll see what we can do. But I think that's an opportunity for FreeBSD universe to actually coalesce together and do something.
Yeah, I would say that from what I've heard from enterprise, which is admittedly not a lot, some enterprise customers would like having this schedule, because one of the complaints I've heard is we have 3 months after a release to upgrade to that before the previous one is not supported, and we don't know when that 3 months is going to start. So having a calendar, they know that they need to be off of 13.3 by the end of September. Or sorry, by the end of December, because that's 3 months after 13.4 will be out. So it will help a little bit with the support cycles for customers knowing when those deadlines are going to be for upgrading. But I agree, yeah, longer support would be great if we could do it.
Yeah, to the point you were just making, I think your new idea of being able to telegraph that 13.4's end of, or 13.3's end of support is going to be December 2024, not 3 months after 13.4 comes out, which you're probably only going to find out about a week after it happened because you're not paying attention to FreeBSD. Suddenly you have a very short deadline is very inconvenient. So yes, you and I talked about this before, and I'm glad to see that we're going to be able to publish the schedule and let people know ahead of time. About the even 4 years of support, how practical is that in the face of things like OpenSSL, which says they're only going to have 2 years of support the end?
Well, we do upgrade OpenSSL within stable branches.
That's a new policy?
Well, not major releases of OpenSSL, but we do minor updates of OpenSSL. So it's
But
not
major versions of OpenSSL are only supported for 2 years now, right?
right.
So like, what's going to happen with 14 when we get to 2026?
We'll figure it out. Yeah, we'll figure it out. As Gordon says, we'll figure it out. We have been figuring this out well since at least 2005, because I remember some of the first issues I dealt with as a security officer were OpenSSL issues where it was not supported anymore, and we had to backport patches, which actually worked to our advantage because OpenSSL had released broken patches, and it was in the process of backporting it that I realized their patches were broken. And fortunately, I was able to send an email to all of the Linux distros saying, by the way, you don't want to use that patch he just gave you. Here's the right patch for you. OpenSSL is better at supporting things now, although, yes, still not for very long. But as a project, we have been dealing with unsupported OpenSSL for a long time, and it mostly works.
But is that same problem going to present itself in a bunch of different components going forward?
Maybe, but no worse than it has in the past, I would hope. Okay. We've managed, more or less.
Maybe in a related question, what's the plan for ZFS versions in releases?
You tell me. I have no plan for ZFS, but I'm not a ZFS developer, so I leave that to the people that work with OpenZFS.
Would you be more in favor of, I guess for 14 it's on 2.2. Would you prefer to stay on 2.2 that doesn't change much, or at some point along the 14 release cycle switch to 2.3?
Honestly, I don't know enough about what is a minor update, a major update in OpenZFS to comment on whether it makes sense. If we would need to talk about how much compatibility do we lose, but I would be inclined to go with whatever you and the rest of the OpenZFS team recommend.
I think OpenSSL is maybe the one example that's kind of the worst case of the one you highlighted, Alan. I'm not aware of any others that are quite that bad. I also know that I believe in the past when we were dealing with OpenSSL, even 1.1 and older branches, that even though the OpenSSL officially kind of would not publish patches, de facto the patches would end up in other Linux distros and they would all kind of get shared among the community.
Yeah, we're certainly not the only operating system with unsupported OpenSSLs.
Yeah.
David has a question behind you.
Okay.
I think it's ultimately more like a comment, which is that all of this conversation around what's happening, upstream from the FreeBSD experience, doesn't it sort of identify that the challenge is on the community generally, and that maybe having a release schedule like this will also allow them to attune more to the same kinds of scheduling?
Yeah, I would hope that announcing this is what the schedule will look like will help people plan.
The steps are just a little bit longer than like 1.5 steps, and I'm trying to not lose it. Yeah, that's the goal.
So OpenSSL is actually, their LTS is actually 5 years. Now, they haven't designated one since 3.0, so who knows if they're going to do that going forward. I mean, another option would be actually if we could get maybe Foundation funds to actually buy a support license from OpenSSL for us to just publish it. I don't know if what their conditions might be on publishing patches coming from us from that. But that would be an option as well, because they still support 1.1.1 for paying customers. That's why the patches exist, right? Because there are people who get them and then they just kind of get shared around. So it's not like people are inventing them; they're actually just taking the actual patches published by OpenSSL. So I think from that perspective, I think there are options. I think things like compiler support is really interesting as a question. OpenZFS and then OpenSSL. I think those are the major constraints to the project around long-term support. I don't know. I know there's some. I don't know if there's any OpenSSL developers in the room, but there have been in the past. But I don't know if there's anything that we can do around that. I will also say, just to quash this, all of the other SSL toolkits, TLS toolkits, they're not any better on support. OpenSSL actually has one of the longer support periods. So if you're going to tell me we should move to boring or something like that, it's just no.
So for the benefit of people online, somebody in the room just asked to look at this alternative schedule that has extra release of the two branches previous.
So with this proposed schedule, there's still a ton of minor releases that we're working on.
I mean, either way, we're going to have a minor release every 3 months, except a gap before a .0 release. The question is, which branch do we release them from?
With the goal to reduce the length of time that you were supporting an individual minor release?
I don't think that's the issue. I think it's more if we have more frequent minor releases, then people don't need to wait as long to get their code into a release, and there's minor releases are less painful to do because there's less accumulated breakage and bugs in the tree. It's just things generally work better if we don't wait as long between minor releases.
Does the same apply for major releases? Right, is it feasible to have a major release every Q2 and then do minor releases Q3 and Q4? And
if we did that, if we did more frequent than every 2 years for a major release, then we run into, instead of saying, do we want to support major releases for 4 years or 5 years, because we can't handle more than 2 stable branches at a time, really, then we're saying, well, either we're supporting 5 stable branches at a time, or we're cutting down the support period for major releases down to 2 years, which I think might be cutting things down too much. So yeah, I mean, doing major releases more often would be great if we had unlimited resources, but there's the frequency of the major releases times the number of major branches we can support at once is how long we support a major release for. So it's a trade-off between those three. Pick 2, basically.
One other thing about more frequent minor releases is then the things you have to backport for patches get the longer you wait between minor releases. And we've had this in the past on a few occasions where if it's been a year since your last minor release, you start to accumulate your security patches you have to backport for P patches start becoming more and more divergent. You can't just cherry pick the thing you did to stable. You're rewriting the patch a third time to cherry pick into the release, which means that's opportunity for bugs to be in your security fix, which is not great.
Another thing that we talked about in the past was kind of changing the way we message things about minor releases, possibly to the point of not calling it 14.4, but just all of them are FreeBSD 14, and this is just the Q2 2026 release, or whatever.
Yeah,
so
I've been saying for almost 20 years that instead of saying that we have FreeBSD 14.1 coming out, we should maybe say we have FreeBSD 14 Service Pack 1. Mm-hmm. Now, people from a Windows background may be scared off by the idea of service packs, but I do want to generally message that FreeBSD 14 is a release, and we have updates to that. In EC2 in the marketplace, I actually have FreeBSD 14 is a product, and then there are updates to that product, but it is still the same product, whatever that means to people.
Yeah, and I think you would scare a bunch of people off less if it wasn't, you're not upgrading from 14.3 to 14.4, you're just installing
updates.
The update.
Yeah.
And I think another thing that we've seen the industry adopt that seems to work well is having the date of when FreeBSD 14.0 came out in the version number. so that you automatically shame people who are still running a software version that says 2021 in the version or something. So even though it's when
I'm
you're running
not
14.4, you got the patches from 2026, but it is still the version from 2023.
Yeah.
And
I'm not personally
a
a big fan of calendar-based version numbers, but we could go that way. But I don't
think I want to lose the regular version numbers. It's just somehow working in there the reminder that no matter what version of 14.x you're using,
it's still
FreeBSD from 2023, even if you installed it in 2026.
Right. And one of the items on the release engineering schedule is email the FreeBSD Foundation marketing team so they can put out a press release about what is new in the release. And in the process of doing that, I sort of realized there's not that much that is new in 14.1 because it's only 6 months since 14.0. So I think over time we will sort of move the messaging naturally just because there isn't that much new to talk about with the minor releases, if they're happening this frequently, to just sort of saying, yes, this is the latest update of FreeBSD 14, the latest update of FreeBSD 15, rather than sort of announcing it as a new release.
I'm just going to say +1 about 100 times so far during your talk today.
Well, we discussed some of this over email several months ago. So
we've had some advantage that way. But even some of the things that I have not seen you mention before, there's lots of +1s from me, at least.
I know Gordon wants to talk a bit about release building security. It sounds to me like there's generally consensus around dropping the major branch support lifetime from 5 years down to 4 years. I'm seeing a few people nodding. Can I have more people nodding? So it sounds like, okay, it looks like there's general consensus. How many people are very much opposed to it? I don't see anybody yelling at me. Okay, so I will send out email, I guess, to Core first, since I think it was Core that approved the 5-year lifetime originally. But I'll start working this through the project in the goal of, well, I guess it only matters once we get to 15.0 because that's when it will change. But announcing at some point that this is the direction we're going to be going to, and then if we're going with 4-year release cycle, major release support, then we don't need to worry about this long support for the last minor release. So I'll just go with this schedule I have here, and I'll start announcing. I'll probably put like 2 years worth of upcoming releases onto the website or something, with schedules for when the release cycles will start and when they will hopefully end. Any other major comments before I hand things over to Gordon? No? Okay, you're it. Do you want to use this mic, or
sure,
in case people have questions for you with that one?
All right, let's see. Don't really have slides prepared for this. So this want to talk. So does anybody not know about the LZMA XZ supply chain attack? Is there anybody who doesn't know about that? Okay. So this is a conversation around that, and so I want to. It's kind of the trusting trust talk. So by the way, my name's Gordon Tetlow. I'm the security officer. For anybody who doesn't know me. Feel free to, we ran out of lanyards, so I don't have a tag. But I want to talk about trusting trust and it's not about the code base. This is about the opaque parts of the project, meaning Colin's job, RELNG, sec team, port manager, and cluster atom. And the question is what is the proper oversight that we need to put in place for those folks? And I don't have the answers here. I'm actually wanting this to generate a discussion. And I know it's kind of hard to have a discussion in this forum, so maybe as a breakout. I want to just kind of talk to it. But it comes down to how do we build assurance for our customers about the binaries that we are putting out. I know that there's been a lot of work towards reproducible builds, but we don't really provide artifacts that show how we went about things so that people could actually reproduce them. And I can also say from my own history, working back and forth with Colin and Glenn before him, that when I'm running FreeBSD update builds, things are a little different. Like they're not like they'll get the bits from release engineering, and when I go to rebuild them for FreeBSD update, it's not quite the same. Generally, a couple binaries are different. Usually we figure that's timestamps and kind of move on, but I'll be honest, I've never really investigated them deeply. So I want to kind of talk about what level of oversight, and it's just about a level of questions, and there's kind of ratcheting of different ways to look at this. The first is like, how do we properly vet people for the different pieces? So I think, like myself, I was talking about this yesterday, I think I've been in the project officially for like 20 years. Obviously most of the people in positions like Colin, like me, have been around for a really long time, but what is our actual vetting process for people having that level of access? Now, but even that, we're all still squishy humans subject to the governments that we live by or actors with rubber hoses and hammers. So how do we provide oversight to the actions of the people with privileged access and provide transparency? Do we need to just build our own oversight function internally? Do we need to have it as a public oversight function that we actually publish, this is how we do things? I don't know if Cluster Atom is, as an example, is a good candidate for that though, because it's kind of bubble gum and duct tape, as my understanding for a lot of the things that are put together. Maybe it's better. And I know that there's a couple people from Cluster Atom here, Philip's not, but it's a little hacky. How do we build out separation of duties inside of the infrastructure so that we have, audit that's separate from the operations and build a tier 2 oversight function? And like I said, how do we get transparency? So these are the questions I kind of put down. I don't know if anybody has any thoughts or questions around this, but like I said, I don't have the answers to this. I'm looking for people who are interested in it. There was a little bit of a discussion on developers, and I just wanted to take the time while we had some to kind of just put some questions out in the room. If anybody has any suggestions, or just find me afterwards. I think we go on break right after this, so we can maybe have a little breakout and a good discussion about it. But does anybody have any comments? We can just start with that. John? Okay.
Thanks. So, there's obviously this matters for various government regulations. The one that I think is probably going to happen fastest is CRA in Europe. And the Eclipse Foundation has just launched, or is in the process of launching, a group to bring together a bunch of different open source, what's called stewards. So that's a CRA term. So it's, foundations / governing organizations that look after open source projects. So, there's a whole bunch of them that are involved, like the Python Software Foundation, a bunch. Anyway, that's a forum that is actively exploring this. So I just wanted to mention it. Maybe you're familiar.
Yeah, I think David emailed me about it, or maybe you did.
Okay.
Somebody actually emailed me about it. I looked at the Eclipse Foundation stuff. It's very early on. They're still trying to figure out what they're doing.
Totally. Yeah.
So that's definitely one I think we should look at as a model, or join as part of the conversation. I think this is an industry issue, right? And state actors are only gonna, only by the grace of whatever deity you may have, like the XZ stuff was found. Had this been 2 years later, we would be having a very, very different discussion. We were very fortunate this was found very quickly. So like I said, I don't have good answers for this. Although I will say we weren't actually affected in our own build system. As much as making all of the third-party stuff is a giant pain, that actually helped us in this case. But I don't want to depend on that as a way to do this. Any other thoughts? Any other questions? Is everybody in the room as depressed about this as I am? Depressed is probably the wrong thing. Staring into the void going, how do we deal with this?
I don't think I'm depressed.
Yeah.
I think in fact I'm excited because this is a really important discussion to have, and
Yeah.
it has been obviously in the in the forefront of our minds as a result of malware attempts in the recent past. But the separation of duties, I think, is something that's kind of an interesting discussion because I kind of believe that transparency is the more important value there, because the separation kind of eliminates the participation on all fronts in the projects. And I think it's more important that there be an open and obvious review.
Well, I think, yeah, so a couple things. Yeah, depression's not the right answer. Well, I think it's depression in the fact that, it takes a good crisis for people to pay attention to things. And the crisis, and obviously the geotan stuff is disturbing. So that's the part that's depressing. Now, it's a great call to action, and it's something that we should be definitely talking about, and that's why we're here. As for the separation of duties, for the operational parts of the project, there has to be separation of duties. That's not really optional, right? You have to have you can't have the people who with privilege are the ones that can influence what the audit says. That's a pretty basic function of any oversight function, right? Now, transparency, I think, is almost a separate discussion because we have a duty to the public, to the users, to the downstream companies to be transparent and build assurance, right? It's about assurance, right? And build assurance in what we are doing, and so we can show to them that we are good, are operating in a transparent manner. But that doesn't change the fact that cluster admin there has to be and there isn't at the moment, by the way, right? Cluster admin basically is everything. And so do we talk about how we break apart some of those functions from cluster admin so that we can say this part is cordoned off and is meant for, I don't want to sign up for more, but is a security team, the people who should be watching over them. Now that doesn't make sense either because I have privileges as well. Now I don't have full cluster admin privileges, but I have privileges on the security relevant stuff. So does that, but what's the right team? What's the right entity and role to provide oversight of someone like cluster admin or port manager or release engineering or sec team, right? Because I'm building binaries. And so there's a level of oversight, and then there's a level of transparency. And I think those can be separate discussions. They're both important to have. I don't know which one's more important to do first, if you have to pick one, but I think they're both important discussions. Anybody else? Are there any questions online? Didn't see anything. Okay. Well, I'd love to talk further about this in my day job. This is actually kind of what I do. So I didn't think my day job was going to ever overlap this much with my volunteer efforts. So, but happy to discuss it further. Please find me. I'm sitting down in the front here, and I think we're going to be going on break here otherwise.
Yep. So thank you, Gordon and Colin. Yeah, so that was our first session for today. We are going to have a break, and we'll be back here at 11 Eastern time, and then we'll start the first half of our 15.0 planning discussion. So yay! So see y'all in a while. Can y'all hear me? I got a thumbs up from the backstage, but what about the people in the room? Warner can hear me. All right, if y'all all want to make your way to your seats. This is the moment we've all been waiting for. Not really. But I don't know how many folks, so how about start with this? How many folks this is your first FreeBSD Developer Summit you've attended? Wow, very cool. Welcome, if I haven't already talked to you in person. So one of the things we do at the Developer Summit in Canada every year is normally we'd spend the first half of the morning, but I really wanted Colin to be able to go first this morning. So we're going to do part of this discussion now and part of it after lunch. So we'll kind of split up into 2 sessions. And we're just going to spend a lot of time brainstorming and talking through things that people want to work on and time for 15.0, which, Colin, if we go with kind of your proposed schedule, what's your, I can't remember, when would 15.0 maybe? By the end of 2025. So use that as your guideline thinking, what's something I can have land in the tree perhaps by the middle of 2024. So think of Q3 2024 as your deadline. Yes. Yes, I should say middle of 2025. It's kind of, for now, for today's purpose, think of end of Q2 2025, what I think is realistic. So we're going to kind of talk about what, we're going to kind of, we have some categories, I'll introduce them as we go, but we're going to kind of talk through different areas of things, and keep that timeline in your head of what's kind of feasible. If something is not feasible in that timeline, then it's not worth bringing up today. Like we'll talk about it, and when we get further along in the future and it falls into the timeline window. But we're going to be focusing on thinking about planning cooperatively. It's very much a group participation session, including folks online, of what we want to kind of, as a community, work on during the next year and a half, I guess, or almost a year until preparing for 15.0. So the first thing we have does not take very long. Well, I should also amend. So we have a hackmd that I occasionally push to GitHub, so it's mirrored over on a GitHub repository I have. Like I have a document for 14.0 as well that we used previously. But this is kind of a living document that gets updated over time. And so over time, as things get done, for example, these things in the completed, the first time when we talked last year, none of those were completed yet. They were things that were kind of in other stages in our workflow here. And then as they got done, they get moved up. And then occasionally we'll update this every conference and sometimes in between. And we can kind of see the history. And at the end of a release, we can kind of see what we ended up, the things that we maybe talked about, how many of them actually got done or did not. So the first thing, or the first category, very short, are things that are completed. You can add more stuff to here that is not even listed if you want. But in general, we like to move things up. So I know I have 2 of the things. I looked at this about a month ago. And even since then, there are 2 of the things down in the current have, which I'll explain in a second, that I can move up. My NVMe stuff, I got committed. So if someone wants to move that one earlier in the table, feel free. Just try to follow the pattern of adding a reference to the commit when it was merged. And I think also Mark told me that one of these, the one that's using like inline function tracing with dtrace, this one I think has also been moved or has been committed and merged, so it could move up to the have. Is that true? Yeah. Quite a while ago, OK. So I don't know if this is just the provider or if this is the wrapper and user space to kind of make it pretty.
Yeah, no, that's still not landed, actually.
OK, all right. OK, so someone can at least move this one. And if you follow the link to the review, you can probably find the commit so that it's easy to tag and kind of match it up. So it is a hackmd, so anybody can edit it. The link should be on IRC and other places. It should probably be on the wiki page. Feel free to splat the link in other places if necessary and help other people to find it. I can't see the comments online, so if you see something that someone says on IRC or if anybody's watching the YouTube chat, hopefully, feel free to jump in on the mic and relay it. Ed is going to play the part of running around with a microphone instead of me this time. So Yes, feel free, especially things that I've done, feel free to go ahead and move it. We'll see if the page auto-updates or not. I'm not sure it always does. We'll see how it goes. Keep in mind that if several people are editing at once, I think HackMD, when you're in the edit mode, will show you that people are nearby you. So try to not stomp on each other's toes too much, but normally it works out fine. So the way this is going to work is we have different kind of sections. So completed is pretty easy. That's not one we talk about too much. The next section we have, which is where we're going to kind of spend our first chunk of time, is like a blob of code that you have, but it's not in the tree, it's out of the tree. Something that's a have is probably like mostly complete, but it might be kind of hacky and needs some massaging to kind of be more upstreamable. But it is a thing that you have that you would like to merge upstream in some form or fashion, but you might need some cleanup. So the thing is kind of a brief description of what it is. Everything on the list needs an owner, which is kind of the responsible person who could be bugged about it or queried about what the status is. If it has no owner, it can't really make the list. And then the last column can kind of get updated based on for example, if a review shows up, it can get edited over time to have that, or if there's a URL to a patch or things like that. So the first thing we might go over then are have. So if there's something on here that your name is already tied to that you want to update, go ahead. Can anyone tell me if it's updating or if I need to switch to it is updating? Okay, mine is. All right, sweet. Okay. So I won't actually talk through these too much, but if people want to add new ones, you can raise your hand. You can edit the wiki. You can edit the page as we go. Perhaps please stay in the have for now if you're like going too far ahead editing until we get to the other sections. But otherwise, yeah, let's do it, folks in the room. Colin, I saw first.
We might go not in strictly.
Yeah, we might go in like, what order does it involve Ed taking 1,000 steps?
I have some improvements to PowerD that hook into patches to the scheduler, which will make it a lot better on multi-core laptops.
Okay, and is that okay, it's a have, never mind, yes. So, can someone edit it, because I'm not near a keyboard. Or I'll have to get the chalkboard out. There, it's happening, okay. Who's next?
So I have a port of the Juniper 9P file system. It's in a review. It is rebasing. It nearly works. So I'd like to get it into the tree soon, so that we'll get people to break it and stuff. Yeah.
Okay, so 9PFS client. Very cool. Brooks, I know, was over here. DFR.
It's a file system. It doesn't know.
Yeah.
So assorted cherry prerequisites. I don't think we'll get a full cherry import, but we're going to start merging constants that we need to reserve and things like that, where it would start causing us ABI breaks and flag days that we'd like to avoid. And we might, how much we merge, I don't know, but definitely some things like auxiliary argument flags, which are catastrophic to everything if you
have to renumber them, yes.
Yeah, ABI bits.
ABI bits, kind of reserving bits of ABI that we know we'll need. And that's Brooks. Yep. Maybe annotate the 9P file system with being like FreeBSD VFS support or something like, so we can mount a 9P file system. Okay.
All right, so I've had for quite a while a diff that will let us build the default TCP stack as a module, which allows for rebootless upgrades to the TCP code if there's a bug, for example, that needs to be fixed.
There are no bugs in TCP.
That's very optimistic. Well, let's go with that. But just in case. The big thing I think it's missing is really all the UX questions about how someone would actually use it. And so the code to make it happen is relatively simple. It's done. Somehow, someone needs to figure out the UX pieces so that we can make it so that it's actually useful for people.
Okay. And that's JTL as the owner. Who's next? Someone just down the. Yeah, yeah. Maybe we can add that. Yeah, we can have that as a need or something. The having a good UI. Go ahead,
Yes.
Olivia.
I will be working on the UnionFS, funded by the FreeBSD Foundation. So I saw a line about overlay FS at the end of the document.
Okay.
And hopefully in 1 year we can have something quite stable. Maybe not all the bell and whistles that I'm envisioning, but something that can be used and tested.
So, well, I'm going to wiggle a little bit. Is it a like thing that's in progress, or is it a thing that's mostly done?
No,
It needs cleanup.
It's just started.
Okay.
So in progress. And
so that'll probably land. We haven't gotten there yet, but that'll probably be
okay.
a new category this year is in progress. So. I think UnionFS will be in progress. Maybe. Okay.
So one that I've been working on is just support for unprivileged Beehive without certain features like PCI pass-through, but like the kind of core, like most of the core I/O controls would be usable. Like I think you'd still have a separate VMM group, and then you'd need appropriate permissions to actually use it. So by default, it wouldn't be unprivileged Beehive, but you don't need to be, or you wouldn't need to be root.
Okay.
If that makes sense.
So does that qualify as a have?
No, that would be in progress.
Okay.
I guess I should just go ahead and have it.
All right. We're kind of mixing, but that's fine. So is it on here already? Either rootless Beehive or something? Is that what you're unprivileged Beehive? Okay. And that's a Mark J. All right. Other halves. Let's try to do halves for a bit. So we wander into in progress.
So I have hierarchical rate limits for ZFS done, ready for review. It's waiting for review. So
That's a have.
I have worked on a graphical inversion of the installer. It's ready for review. Needs polishing in some places, and also your opinions.
Yep.
Sorry, happy to discuss it.
What am I on time too?
Back to the 9PFS thing, we in Juniper actually have some private changes and fixes around the file system that's not synced up yet with the public repository. So hopefully can join effort on making it into the tree.
Well, so we can maybe head more towards the in progress things. So in the past, we kind of didn't have a separate in progress. And the other categories I'll mention that we'll get to later are things that are not yet in progress. And we have them categorized as things that are a need, like you need this for a project you're going to do, and things that are kind of a want, more of a nice to have. And those will be more what we get into after lunch. So just in terms of framing about how to categorize things. In progress is something that you're kind of currently working on, or you have a partial implementation, but it's not really a have. It still needs a fair bit of work before it's going to be ready for upstreaming. So it looks like people have already added several things, like an IMU driver for AMD. I know the foundation mentioned that yesterday. Constantine is happily Well, I don't know if happily is the right word, but he's working on it.
Oh, he's happy.
Oh no. I don't know what that means. Maybe my Wi-Fi is dying. CertCodal. So is this, Alan, are you volunteering Des to do this? Or did? Okay, so that came in from Iris from online. Did Manu add this, or did Warner add this on Manu's behalf of pulling DRM back into base? Okay. Do you want to say anything about these two items you added, Warner? Oh, do you need? Okay. Oh,
I have the mic.
Okay.
I have
fine.
A patch for dtrace SDT probes, wherein you can create a probe in your code without having this ugly memory access and branch that we currently have. But it uses
Okay.
a compiler feature called asmgoto. And LLVM, sufficiently old LLVM versions don't support that. And as a kind of side discussion, I'm wondering what is the sort of minimum required toolchain we have for the kernel these days? Because I know like the Mac OS CI job uses LVM 13 or something like that, which is too old, which is the only reason I haven't committed this thing.
And I think it's somewhat arbitrary. We've just kind of we've left some of the little CI jobs kind of pinned at whatever we think the oldest is to kind of keep it working.
Okay.
But not because, like I think now we even have a gap in the middle. Because I think we have like 12, 13, and 14 in the CI actions, and we're up to like 18 in head. So it means that we don't actually test something in the middle.
So I guess the question is, does anyone care? Like, who cares about making old LLVM versions work?
Yeah, how old are we?
I think asmgoto appeared in like 15, 16-ish. So older than that.
I know Cherry folks care about LLVM 15 because I think that's where Cherry LLVM is at.
But there's no dtrace there.
Not yet. Do other people have a vested interest in? And the other toolchain question is, what about GCC?
It compiles with GCC. I haven't actually tested it.
We mostly only test compiling with GCC anyway. A lot of it's about wording coverage and so forth.
It's nice if it worked, just because it's such a weird compiler feature that I want to make sure that I haven't done anything. I think what I'm doing is pretty
Okay. So, because I think Mark wasn't mic'd, so for the stream, we believe that the current versions of GCC we support would work fine. With that, it's really just a question of LVM versions. Warner.
Okay, so the things I added are devd events for errors. We record a little bit of data, and we'll do the full sense buffer for SCSI and a few other things for NVMe. I have that kind of working, but it's missing a couple pieces. NVMe reset and recovery just needs final testing in a harsh environment where I need this. The non-harsh environments, it's working fine. K-boot support for AMD 64, it's about 80% right now. It'll panic in the middle. I'll be working on that this summer. And Chuck Tuffley and I are working on Linux IOCTL compat for NVMe, so you can run things like NVMe CLI either as the Linux binary or as a native port that I've done on FreeBSD. So.
And if you get a chance, if I know you have an open review, if you can add the review URL.
The which one?
Oh,
the URL. Okay, yeah.
Yeah.
I thought you were asking me to add one more thing, not
no,
the
no,
URL for it.
No, but like, it's nice if we can actually put the review.
Yeah, I'll add that as soon as I figure out which one it is.
In which case, that's actually more of a have, quite frankly, if you're to the point of having a review rather than an M. Okay. Oh, we need the mic.
So I have some stuff for Beehive that adds direct Linux kernel loading support. So if you've used QEMU-kernel like that, so it implements the loader protocol, puts the kernel right in there. You don't need a disimage and stuff to boot off. So it's really good for like just really fast one-shot VMs, and it kind of it benefits a lot with rootless beehive, and it would benefit from 9PFS as well. Like they play in similar areas. So I have a working prototype of that, which I'll be presenting in a couple of days, but I've pushed it and stuff, and so there's been it's far enough along that it could be.
Sounds like a have to me.
It's pretty close. This would be my first work of any substance, so it's like I don't entirely know how to judge the size, but I think it wouldn't be a big lift to have it done in time.
Yeah.
And
if it's functional, that's more of a have than an in progress.
Okay.
So I think that's a have.
Okay.
Yeah, I think have really is code exists, and the reason it's not in the tree yet is review or need help with
refining for upstream or things like that.
That sort of thing, yeah.
As opposed to like it half works and it panics if you like look at it weird. That's more the in progress. Okay, some other ones that people have added that we haven't talked about yet, maybe. Do you want to talk about Splice? You mentioned it yesterday, I think, Mark.
Yeah, so this is a feature. It's an interface that comes from OpenBSD, but it basically lets you take two TCP sockets and just splice them together so that data received on one socket is automatically transmitted on the other one. So you don't need to bounce all of your data through user space. So that's useful for at least proxies, and we're planning to make sure that it integrates cleanly with KTLS so that you can do you can basically intercept TLS sessions if that's what your policy says you need to do. So hopefully with less overhead than what you'd have to do today. But not as general as kind of Splice in Linux, where you can kind of take arbitrary descriptors, in theory at least, and bind them together. This is a more targeted interface. And it lets you do things like, after n bytes of transmitted data, you can unsplice, or after some timeout. So there's a bit more room to, define policy around that.
So for the stream, that's Jonathan saying that Mark should talk to Drew. All right. Do you want to say anything about this, Brooks, versus what's on the slide?
Yeah, so I'd like to finalize the ABI for libc at least, or for libsys, so that we can claim some sort of stability and start pushing language runtime vendors to use it. The main thing that I have at the moment is that for upgrade compatibility, I want to put stubs for the public symbols in libc. That's going to require some slightly evil generated C, or else even more horrid assembly tail call. So I don't want to write and debug assembly tail calls, so I'm not going to, and make the compiler do it for me. But it should be straightforward. I'm basically at this point going to wait for Kyle's GSOC student to finish work on make syscalls.lua before I add a whole bunch more crap to it.
Yeah, maybe.
Yeah, for those who don't know, libsys took the actual making of syscalls out of libc and put it into another library, which is a filter library. So it's basically, it puts them all in one place, makes it easier to restrict them, makes it easier to handle compartmentalization. Also, potentially, you could replace the implementation, so you could have a wrapped implementation. There was some work at Waterloo that did that. So, yeah, just try to sort of decouple libc from the system ABI interface.
Do we want Brooks to start trying to tee up language runtime maintainers to schedule or plan for this? I'm thinking of the ordeal that we went through with Go and with Rust, trying to move from a long ago deprecated FreeBSD to a less
still deprecated but less deprecated
less deprecated FreeBSD.
Yeah, I guess my thought there is that I would like us to start working with them. The question is probably, I wouldn't MFC the split, but I might MFC the existence of libsys. However, it wouldn't really be an MFC. It would be like just grabbing the stuff and moving it. There's just too many commits. There's something like 100, there's well over 100 commits to do the split and address an assortment of long-time deficiencies in our symbol tables and things like that. We've had terrible hygiene in terms of maintaining symbol versions, and doing things like losing symbols over time has been something we've definitely had happen. And in fact, in the time between when I first turned on, hey, you can't link unless you have all the symbols that you declared, and when I had to back that out and then reapplied it,
we gained new ones.
It took me several days to fix all the regressions. So quite a bit of work. I guess I will say one in progress that I'll mention is a slightly better symbol ABI checker that would both tell you, will rather than saying, okay, if it's declared in the symbol file, it has to exist, it would be a dump of all the symbols and their versions. And then you can, you'll have diffs you'll have to update every time you add a symbol to libraries that we choose to add these things for, but at least have a bit more ABI stability. It's not a full ABI checker, because the full ABI checkers are like, giant piles of Perl and Python that parse ELF and dwarf and all sorts of things. But it would be something we could have in tree. And so I want to finish that.
Okay, so a lightweight user space ABI checker might be the way to describe that. Okay. One thing I think we didn't do, we also want to go through things that are on here to see if any of them are stale or no longer relevant. So I don't think we did that with have, the stuff that was here from before. So Pavel, you have these two. I know you've done some things with copy file range and some other utilities. Reload the page. Oh, okay. Well, we'll see if it works.
So copy file range is in install done
Okay.
by Martin Matuska. I have a patch for a simple API, and I replace all the individual calls to copy file range and fallbacks to read write with a simple function in CP install mv and cat. So that's there is a PR. One objection is from DAS that it might be better to bring copy file API from macOS. So Bruce Evans declared that he would like to take a look. Sorry. Jesus, sorry.
Yeah.
Yeah. I forgot who was that.
Kyle, I think.
Kyle. Okay.
Close.
Sorry, guys. So yes, so I will wait for this if he decides to do it or not before merging. So.
Okay, so that's kind of the wrapper, and I guess, all right. So they're all still coming.
I will update with yours.
Perfect. Has the SV stuff, does anyone know if that's all landed or if that's still in progress? For
Hopefully the
ARM64?
stream will respond in a moment.
Or we could, if the review is still open, then it's clearly still in progress. I know I've talked to Mark about this one earlier, so I think it's still in this state. It's not certainly not done. It's still a have. This is the kexec kernel for crash dump thing, I think.
Yeah, we're waiting for a project to start that would give us some time to actually upstream it. So the implementation is done. I haven't rebased it in a while, but if anyone's interested in it, I've talked about it several times before. It's basically a mechanism that lets you kexec a rescue kernel after a kernel panic, and then you can, configure that kernel to dump all the memory to a file system. And so that way you don't need a dedicated dump device or anything like that. But it does, yeah, there's the functionality is all done, but the UI probably needs a bit more refinement. But yeah.
And then, so IOVEC wrapper is the thing we have in CherryBSD. What are your thoughts on that?
Yeah, so I have a set of wrapper macros in CherryBSD because the casts all vary in hybrid kernels where some pointers are capabilities. I think it's generally a readability improvement versus having to do casts and to do addition and things like that. So it's probably worth merging, but I just haven't done it.
Yeah, so I think like for folks who may not know, I think like there's a macro to like initialize an IOVEC, like you give a pointer to the vec and you give it the base and the length and it does it for you.
Yeah.
Which avoids some duplicated code often when you're going through a loop and populating the darn things.
And there's also
and there's like an advance, which is really useful, right? Which moves the pointer and decrements the length and things like that. Yeah. Okay. So hardware watch points in Beehive. So Bojan is now a committer. But he was a GSOC student a couple of summers ago, and some of the work he did was single stepping for AMD CPUs that has been merged. I don't recall if this part is in his Git branch or if he's actually open reviews, but he had changes to allow you to, it kind of violates the guest if the guest tries to use hardware watch points, I believe. But otherwise, you can kind of use hardware watch points, like the debug registers on x86, to set a breakpoint or watch point when your guest is running to use over the GDB stub, which is kind of nice. And I know he has patches to do that. I just don't remember if they're in a review or not. We already talked about the inline function tracing. Chuck is here. Yep. Still a have? Yeah. Don't have the mic yet, but we'll run it to you.
Yep, that's still a have.
Okay, for Squash FS. Okay, Colin already mentioned PowerD. Okay, I think we've talked about, this is hierarchical rate limits for ZFS and Pavel. All right, that's perfect. Okay, so I want to make sure we got through all of those. Let me look at the time. It's 11:30, so we've kind of made it through our first half hour. Why don't we start, and we may not quite finish through lunch. Let's talk about the next category. So the next two categories are a little more like there's maybe not code yet or very little code yet. So these are a little more wish listy, aspirational. But the first one is something called need, which is more, it's a wish list thing, but I really kind of need it for something that's going to ship using 15.0. Like if I'm building a product or I'm building a service of some sort, I really kind of need this as a thing to make it viable, as opposed to a want, which is much more, I mean, that's kind of a pony, unicorn, fairy in the sky sorts of things. We have several in here already. I still need a new ELF kernel dump format. In Cherry, we have extra metadata stored in RAM, these kind of 1-bit tags associated with words, and I've defined it. I've negotiated with, because ARM also, we kind of negotiated a way to store this in core dumps for ELF for user space, where we store packed bit masks of the tags for RAM. And I need to do that for kernels as well, because when we have a kernel crash dump, we want to be able to see which pointers were valid or invalid. And our current kernel crash dump format is very bespoke, and therefore not very easily extensible. And I have various ideas in my head of how we can make it be an ELF file again and just have some tweaks when necessary, in which case it becomes a more natural way to store things like memory metadata in the core dump. So that's still a project I have, but I have not started. Maybe I'll get to it this year. Finished package base is a very broad topic.
It is. I think primarily what this is just dedicated effort and time to working through the long tail of issues. And so
could we make this more specific? Like
there are some specific known issues.
Like the installer.
The installer is one.
Should be its own item, maybe?
Yeah.
Someone wants to add a wooden road for that. Are there things, so package groups and BSD install?
I mean, so we should split this out as we're going here. And
Okay.
so BSD install support for package base should be one item that's on
Whoa,
here as its own.
What in the world happened there? Okay, there we go. It's fun watching it get edited in real time. And so do you want to say anything about package groups and what that means?
I will defer that to the IRC commenters.
Okay, yeah. Fair enough. Okay, well, maybe they can update the file as we go. So Colin said we also need package base as part of our release process. I know, yes, yeah, fair enough. So that we ship release. I mean, this is kind of, yeah, these are all kind of tied together, but yes, it's good to have that as a separate line item. Ideally, we would kill this item by just having it be split out,
yeah.
Honestly. So maybe if we can add a package groups and then maybe.
Yeah, package group should be its own item. And I don't know if we want to call out a separate entry for package base integration and testing, or that's just implied.
Okay, probably we can leave that implied. So, but these three things are better than the one that was there before. Yeah. Alan, do you want to talk about this one at all? If it's still on your need list?
Yeah, this is just to be able to make jails in Poudre that don't have a toolchain, so that if you're building your own installer ISOs or a VM image or something, that you have the ability to do that, even though the jail you're using to build it doesn't have a toolchain.
Okay.
Kind of related to wanting to make it easier for people to build a custom release of FreeBSD and get more of the process closer to the way release engineering does it, but with the kind of ease of customization that Poudre offers with its overlay support and pre-install these packages and so on. That's very difficult to do with the regular make release process.
Okay. Next we have, this is something Brooks talked about last year, external toolchain support, which I think means not supporting external toolchains, but moving our current toolchain to external. Yeah.
Well, I don't think we're intending to like kick the toolchain out for 15, certainly, but continuing to support things. I think I mean, on Cherry we don't use the internal toolchain at all, so I think just continuing to make sure that works as a first-class thing. I guess there's a longer-term need to understand how we bootstrap a toolchain to do a release in a way that's replicatable and sensible. And I know how we do it for Cherry BSD, but that's not probably how we would do it for the project. So we need some concept of, where did the toolchain that builds the release come from? And that includes package, the whole thing, not the bootstrappy thing.
So pre-commit CI, this is a probably a very broad thing that maybe needs to be split up. Like Bricolé, I think, is a have. Perhaps it exists. It's a have. It's not like a. So probably that needs to be its own item with Mark. Make CI is also kind of. I mean, it's part of it's in the tree. So I'm not even. But maybe that's a have, or is it a? I don't think it's quite completed. Who wants to speak to that one?
So make CI is not useful in its current form without extra work for vetting whether like a pull request is good. You need to do a few things to make it useful today, and I'm sure people have other problems with it as well, but that's where we are right now.
So could I suggest a need is like make CI improvements or like make CI feasible, or not feasible.
Yeah,
Make CI improvements to aid with like merging external contributions. That's really long, but something like that as a line item.
Yeah, we have like 8 different things around pre-commit CI. I think they should each be their own line item.
Yeah, that's what I'm trying to angle for. So I'm trying to how to like pre-commit is a have. I think saying something about make CI working better for merging PRs is a need, and that will be its own line item. And some of these other ones, it would be nice to split those out instead of kind of having a giant thing that you could ever check off. So I don't know if whoever added stuff, if you want to split some of these. I know we talked yesterday about someone who has a project that gives you it's a fork of GitHub's internal action runner stuff, and you can implement your own kind of runner backend, so you can run actions locally as opposed to in GitHub's cloud. That's probably its own item. Yeah, I'm adding that one right now. Okay. All right, so I assume y'all are splitting this one up. Who wants to talk, or does anyone want to talk about this next one, pre-commit CI with ports? And is that still a single thing, or does that also need to be somewhat split up?
Yeah, currently I'm not looking at it yet because I try to focus on source and ports and source and doc. And to my understanding that Baptiste has some thoughts about that, and Moin have some proof of concept of that based on service CI, but I guess he doesn't update it for a while. So to be honest, that item isn't edited by me, but I can check with him to have better understand about the status. Yeah. The one thing I did like to add is for port CI, the major challenge is that it usually needs to deal with when a very deep dependency gets updated. That will cause very many packages needs to rebuild, and that takes a lot of time and computing resource. That's a major issue need to be solved by for really useful port CI.
Do you want to refine this, going back slightly, make CI useful for committers? Do you want to be more explicit, like for committers to test a patch before pushing it? How do you, okay. Okay.
So there's 2 audiences for make CI. One is for committers who have made a change and want to test everything out automatically, maybe without having to build their own Jenkins install locally. And then the other is using it, and maybe we need 2 different targets. The other is using it for contributors outside the project who are contributing. We can vet those contributions before we push them in, whether they come in via GitHub or pull requests or whatever. That's the second thing. And I think those 2 use cases overlap 90-some%. But that's kind of that's why I have the 2 different things up there.
Okay.
And I'm only signing up really for the second one, but I think we need to coordinate between Lee Win and I, and Moen need to coordinate on what's going where with this stuff as well.
Okay. I mean, I think for now, if we don't have a person who will at least will volunteer to answer questions about what it means, then we kind of need to probably take it off the list. But okay, you want to? So Lee Win and Greg. Greg, you were first. So how about you go?
For the first item, I and Moin can take over that because the first item is part of Moin's foundation sponsored project.
Okay. All right.
So yeah, kind of general category is just AI support. So that could be CUDA support in FreeBSD. That could be, well, included in that would also be, more complete support for DPUs in FreeBSD. And as far as owner, I don't have a clear idea of that right now, but I would like.
Give me the point of contact at least.
I can be the point of contact for sure. If folks are interested in collaborating on those things to make sure that FreeBSD can support those workloads really well, Ed and I are thinking about how we can facilitate that.
Okay. My only thought on that is, do you qualify that as a need or a want? Like, how strong is it? Like, do you have specific kind of vendors or customers in mind who need it?
Yeah.
Okay. So that presumably is someone added to the bottom. Well, just to the end. It's like an append journal. Where were we at? Local and cloud developer CI. Okay. I think local and developer CI is kind of, is that the same as this one? Improving make CI? Okay, then maybe merge them. Okay. If you don't know what it is, just take it off for now. Because this is also just too vague. Like, I think it's helpful to have concrete things when we know when they're done. And that one's, we don't know when that one's done. All right. Kill it. All right. It's gone. Problem solved. I think, I assume this is on IRC, Universal Flash Storage Driver. Does anybody in the room want to say anything about this? Warner doesn't want to say, but he's raising his hand.
Warner has to say something.
Yeah.
Yeah, so this is used for both embedded systems and the early boot on x86. So if you wanted to create a Linux boot image for x86, you would need to put it inside of a UFS driver. And it would also be useful to have it more generally for the system. I'm not entirely sure what what this means to him, but that's kind of the extra context around that I can give.
Okay. I'm going to punt to Mark about this next one to see if he has any ideas, just because I know you hack on dtrace.
Dtrace-C works. I used it like, I don't know, last week. PR not submitted yet. Like pull request?
I think he means bug report, is my guess. See many include. I'm not sure what that means. I wonder if is it the thing where sometimes you can have stale things in like the proc.d and so forth, and it gets unhappy. I mean, that used to be when we ran out of types, which we've now fixed by bumping the size of the number of types we can have. But I wonder if it's something like that.
I think I see that. So, okay. So dtrace actually has a kind of, it has a, like it can parse C declarations, kind of.
Yeah.
So you can include C headers in your scripts.
Right.
And get constants. And apparently there's problems with type defs getting redeclared.
Maybe it's hard to see on the screen, but the report is about capital C, and the other part is lowercase. That's capital C, and the one on the right is lowercase.
Oh yeah, because okay, dash capital C is the thing that's like, yeah, run the preprocessor. Okay, I'll take a quick look at this.
Okay, maybe we can just add Mark J to the as a comma, another person to the person field. Okay, does anybody want to talk about this item of refine BSD user support for release process? It's a QEMU thing. Okay, we're on this side. We'll start on this side and we'll wander to, then we'll make Ed walk all the way across the room.
So a while back, I added some support. So let's wind back a bit. For BSD static user, you can tell the kernel that when I try to run this ARM64 binary on my x86 system, use QEMU instead, right? And there's a facility to store these mappings of ELF binary to helper. And I implemented a concept which was done in Linux first to allow the kernel to pre-open these emulators so that jails don't have to have the binary installed. The kernel already can access it because it's got an open vnode. And using that required some changes to the QEMU ports to stop it from kind of trying to work around me. I don't know quite what the status is on the QEMU side. The FreeBSD kernel support has been there for a while. It could probably improve its support for jails. I know Colin wanted to isolate this behavior to a parent jail, and that requires some changes. But if you're okay with just what you do on the host is available to all my jails, then it works there.
Okay, so I'm wondering if we can split this up a little bit. So one of them, I guess, is playing nicer with jails or allowing jails to constrain it.
Yeah, just to elaborate a little bit, most of the release building process is just your standard cross-build FreeBSD image, FreeBSD build world and so on. But we do need to run a couple things under emulation for building VM images. Sometimes we install packages which may have their own install scripts that they run. We need to run LD config to set up library stuff. So there's just a few commands. It's like less than 1% of the build process, but we need to run a little bit under emulation, so I use QEMU for that. And there's just a couple oddities, like on ARM64, we try to set up the bits for 32-bit running 32-bit ARM binaries under ARM64, which QEMU gets confused by. Right, but I'm currently running the old one, so it's stuff that needs to be cleaned up between me and the people that know about QEMU, but we'll get it sorted out.
Okay. So I think this split sounds good. Are you happy with that, Warner, or do you want to say more?
That's fine.
Okay, Warner says he's happy.
I'll talk. So the 32 on 64 is half committed on the QEMU side. It's committed to the new stuff, but not the old branch. We need to update the old branch or kill it or something, and that's,
Fire. We're
yeah,
getting
that's
to that.
proving to be difficult. Also yesterday, Mitch was saying that the package build is totally broken on RISC-64 because of Poudre issues with QEMU and emulation and core dumps, and that's as far as I know. So that needs to be investigated and looked at and see if it's some trivial thing or some big massive undertaking or whatever. So that's why that's there.
Yeah, so Gordon's question in response to you is that a need or a want?
I'm not going to debate the fine philosophy of this. It's something I might work on in the next year, maybe.
Okay.
So if somebody wants to move it, great, but it needs to be on the list.
That's fine, yes. There's two more here that have you. We've talked
that might be the runner for pull requests might be a want.
Okay.
Not a need. I'm happy with that. But the GitHub action for quality of experience is definitely an urgent need that I need help with, so that we can, as we get more pull requests, do more things automatically, like immediately tell the user, thank you for the contribution. Here's what's wrong with it, so that people don't have to do the initial triage that I'm doing right now. So, you know, stuff like that. And we need people that have experience and expertise in the area to work on that. I do hacky things occasionally, but I'd like some help with that. So
Okay.
so
I
I'll
think
coordinate it, but I'm not going to do the work on either one of those.
All right, fair enough. I think for this one, I think the URL was posted in IRC yesterday, but there is a project Baptiste, I think we've talked about it, be pointed to as the thing that's a clone on GitHub of somebody who's re-implemented the GitHub runner API, and that's what allows you to run it locally. So it'd be nice to drop that URL in this item, if someone can find it. So we've got a few minutes left before lunch. So maybe let's still talk about need things. We can always do more need things after lunch when we come back. But are there other things that folks can think of that they believe they will need in the next, or for a product that's going to ship on 15.0? So the product might not be, or service or something, until 2.0. And I want to call out one thing. I know you're coming up. Lots of times, this discussion really originated coming out of what are our downstream kind of appliance consumers need. One of the things that happened in core this term is we had a bit more balance of more ports people in core. And so one of the things we found out is one of our internal discussions, I think it was Tobias who brought up and said, we really need iNotify. And that was something that had never kind of been voiced over to source world, for lack of a better way. So we would like to hear things that are not just, what do I need to make my embedded appliance work? What do we need for things that will, and we know some of them are obvious, like Wi-Fi, that's not terrible. But what are some things that we need for things like a better desktop experience that our ports folks are aware of that are a gaping hole they need some help from source to fill? So those are also things we'd like to hear, not just what do I need for my storage appliance.
I guess one fairly big thing for framework laptops is that for the newer chips, they don't support S3 sleep states, and they only have SOIX.
Yes.
And, FreeBSD doesn't support that yet, and I know a guy from Intel worked on that, but I think that kind of got abandoned. So yeah, I think that should be a need.
Yes, so S0IX, if it's not on here somewhere, should be on here. It's not on here yet. Yeah, it needs to be. It probably needs to be a need. So whoever's adding that S capital 0, then lowercase ix. It's also the idea of doing it. I think the way the Ben from Intel worked on it and the way it was first implemented in Linux is they basically implemented a software S3. So they would just suspend the whole system. But really what you want to do, the mature thing, is you want to selectively figure out what things I can power down and only power up things on demand, which is what you really need for other platforms like ARM, where you don't have a firmware giant knob to say, go to sleep. You have to kind of own the powered states of all the things in your system. And we should throw iNotify on the list, and you can put Tobias as the TC burner is the person who asked for it. But that's a need that should be added. I'm wondering if I've gone stale again. Nope. Okay. Are there other ones? Well, those hopefully get added. S0X and iNotify. Are there other ones people can think of? We also, actually, it is 11:59. So why don't we pause where we're at now? Yeah, I have them stuck in my head, so I'll make sure that the 2 ones get added. Why don't we go ahead and pause for lunch now? During lunch, you're free to kind of let your juices, well, how do I say this not terribly? That was not the right way to say this. Have an opportunity for your brain to relax a little bit and think about other things you want to talk about when we come back. So when we come back, we'll start off with a little bit more time if folks have need items, and then we'll move into the more wish listy things of want. And then the last thing, the thing we have to talk about, it's lots of fun, fire and axes and things we remove from the tree, and make sure we actually do some of these things, fire with fire. So we will talk about that too. So think about not just things that you'd like to have, but things that need to go because they have overstayed their welcome or just they're too old or whatever reason. Also, immediately after lunch, so lunch is about an hour
or an hour 15. I gotta look at the schedule. I think it's hour 15. So lunch is from 12 to 1:15, but be kind of back in the room. Meet back here like a 1:05ish or so, because we are going to all go take a photo together at 1:15. But we need to meet here and have time to figure out where we're going to go and go there and take said picture, and then come back and aim to start back up here at around 1:30. So, sound good to everyone? All right, let's go have lunch. which is very cool. Has a nice timeline inside if you haven't seen that. We have a few T-shirts and stickers, and Antithesis brought some swag as well that I think I'll let the gentleman from there introduce when he comes up to talk. And we have a few more T-shirts. Well, you may have to hunt for sizes. We have small, XL, and 2XL. All right, the XLs are gone. Alan has taken the last XL T-shirt. So with that, I think we can probably resume talking about 15.0. So let's see. There's Ed. He gets to have the mic when he's ready. That's OK. I'll give you another minute or two. So where were we on here? Oops, if I have the mice in the right place, the mouse. I think we were at the end of need. Is that correct? And this is stale now. I think it's being fixed. Sure, I wasn't editing it. OK, so this will be the last call for anything in the need, correct. Anything in the need action before we move on to more wish listy things and then get into the best part where we pull out the axes and apparently the F word that I can't say that's not that one in a building. So anything else that people have that is a kind of thing you really need as opposed to something that's a wish list that would be nice and ponies and unicorns and fairy dust? Or we can move on to ponies and fairy dust. That's an interesting question. OK, well, let's do this. So
yeah, do we need a strategy for OpenSSL or other upstreams as a need for 15? So
can you want to be more concrete? For example,
so specifically for OpenSSL, right? The current version of OpenSSL 3.0 is deprecated as of 2026. That's the long-term support version. There is no version at this point that's longer-term support. Supposedly, let's imagine they come out with 3.4 and they're going to say that's going to be long-term support.
Right.
We will need to move towards that for 15. Would be what my statement would be, from my desirements as the security officer having to deal with it for 4 years.
So I'll hear you. I'll ask you a question back.
Okay.
I can't remember. Because I think it's also changed since the last time I looked. Does OpenSSL have a stated policy of when they're going to decide a branch's LTS? Do they do an even odd thing? They just pull it out of their tush? OK.
Yeah, so it could just, well, and like I said, like it's funny too because OpenSSL 3.0 is going to be maintained longer than 3.1, 3.2. They have not established a 3.3 policy yet, so maybe 3.3 will be the next LTS.
So one question I have is, would there be any reason, I can think of some other reasons. What about, should we be tracking a newer OpenSSL in main, even if it's not in 14?
That would be the question that I would say.
In particular, I know we've already pulled, Mark has done somebody else, they've pulled in like some of the optimized assembly routines for things like AVX 512 and other things that are only in 3.1. So we've already diverged with the crypto bits that the assembly crypto bits that we use that are effectively from newer OpenSSL already. So it would kind of clean that up if we
it might be a good idea to move to 3.2.
Newer OpenSSL in main.
We may want to track closer to head OpenSSL in main. So we're. I don't know. I don't have the answer for this because there's no place that we can stake a claim. Maybe we can reach out to the OpenSSL folks and see what they're.
That might be useful to give us some guidance about, like,
I can do that.
Only go this high. Only go to 3.2 because you'll be happier than if you try to go or 3.1 or something. If they were willing, I feel like they're not going to be willing to say anything useful, but if they would, that would be useful.
Well, yeah. I mean, we can at least have a conversation with them, and if they say we don't have an answer, then that's at least an answer of no answer. But but they may be like, we're thinking that 3.3 will be the next LTS, in which case we should go ahead and start
getting to 3.2 now because that'll make it less painful.
Yes.
Yes.
Now I do think that as time's gone on, and someone can correct me because I'm not the one who actually does the work, but OpenSSL has actually done a decent job of making it less painful to upgrade now that we're past the couple of the versions. Well, a lot of the they've moved everything to being opaque already. They've moved a bunch of stuff, so like the API is more or less stable.
Well, so I took a look last week. We still have bits in the tree that have the macro and C flags to say that we'll still use, we won't complain about things that were deprecated from 1.1 that we've.
Well, okay, yeah, we should probably fix that then.
Well, yeah, so I went to fix one, the KTLS tests that I wrote a while back. And they use what should be the generic EVP interface for doing like Macs. And it's really the Macs that are a pain. Apparently with ciphers, you can still call it a built-in function to get back your like class for a cipher. But for Macs, you're not supposed to do that. You're supposed to do something where you pass a string name of what it's supposed to be to get back a thing, and then you have to pass a string name of the type of Mac construction you want to do that you kind of layer and build up. And that's a little clumsier than actually the old thing. So I looked at it and kind of sighed and sighed, because that's...
I don't know what to tell you.
I mean, we're stuck with it, but that one I looked at and I said, that one, a lot of the changes in 1.1, yes, it's a lot cleaner, opaque, yada. This one is more shuffling deck chairs or something.
Yeah.
But.
Anyway, so that might be something we need to figure out.
Okay, but all right. What do we want to say? That's a good one to say. My guess is we do want to actually probably sooner than later start going to a newer 3.2. Related, we were talking during the break. Do you want to say anything about what we should do about a FIPS module, or how? Do we want to put that in a list somewhere? Is that a need?
That's probably a want.
Well, but is it a need that we should fix it?
Yeah, that's probably true. We should stop shipping the FIPS module.
In
because
main?
the one that we ship is not a validated FIPS module, and you can't actually use it for the purpose that it is intended. So we should probably stop shipping it. Now how that's going to work with probably putting a port together, that would be the properly validated version.
Okay, yeah. Or do OpenSSL FIPS more correctly, might be a way to state it.
Yep.
It should be a port that's like the approved version, and we shouldn't build it as part of source.
Yeah,
that's
summary. The gist of it. Yeah.
Okay. Then I think over to Brooks.
Yeah, I guess I was reminded of the related issue of the deprecated SSL stuff. There's a portion of the build where if you build with -s, make -s, then there's a section of the build that is just spewing deprecation warnings. So it'd be nice if those went away.
So I have a general want. I think this is a want. I would, there's the wrong button. I would like make-s to be less crap. I know there was a while we've done some newer versions of LVM, and we'll add a warning that is really noisy, and so we'll just make it nowhere for a while. And some of those I've managed to go kill. I would like us to, it's a good exercise to try to avoid having lots of no-error warnings. Like either it is completely bogus and we just turn it off. But if it's just tedious, at some point we should do some of the tedious bits and get it to where make-s is not a complete trash fire. Would be my personal desire. But that's definitely a want. Definitely not a need. You're very weird people. Okay, at least drop it there, yeah. Okay, any other needs? I like this too. That's kind of cute. Any other needs? Or we'll shift to want. It'd be a fine thing to do. Okay, so let's talk about.
Yeah, sorry. I have a question about the FIPS module in OpenSSL. Do you mean it's not validated because it's not certified by some entity, or because by default OpenSSL doesn't have the hash which authenticates it? There's an entry in the handbook how to do that, and I was wondering when I was doing the integration if this should be shipped with this fixed by default or not, or if this is what you mean. But
no, you can't. So FIPS has very specific procedures where you have to have the install generated on the machine that it's going to be running on. So we can't ship that. They need needs to be done as part of the stand-up process for it. So that, and then additionally, the FIPS module is only validated on certain versions. Like 3.09 is a validated version. You can use it with 3.0.12, I think was what we shipped to 14.0, but you have to use you have to mix it. So it's kind of a weird procedure.
Okay, so let's shift to unicorns and fairy dust and ponies. So I already mentioned make-s. So let's go things that are on here to see if they should stay on here or if people are still interested in them. TPM support, I don't think that I've seen this fly by as in review or anything, but I assume this is for storing the key that you would use with Jelly or ZFS for. And you're still interested in this? Okay. Any update on like a chance of making progress or anything or a timeline? Okay. Fair enough. Is this very closely related to the next one? I guess okay. Okay. Anything else you want to say about it? Oh yeah, sorry. So we should make sure Alan actually get everything on the stream that you said.
Right. So for the TPM support, it's mostly still something that we want, and there's not really been any progress yet. But ZFS encrypted boot support. So this is if you're using ZFS's built-in encryption rather than Gelly. Getting that support into our bootloader is on our list of stuff, and Tomas has the start of some. He's done the investigation and has an idea of what's required. Likely this will only be supported in the EFI bootloader because there's just not enough room in the legacy one, and you shouldn't be booting legacy anymore anyway. But yes, that one we actually expect to make progress on before the end of this year.
Okay. This is an Ed, and I don't think John's at the conference. I don't know if he's here today. Oh, yes, okay. But I think we know what this is, which is that our current SMBFS entry kernel VFS thing is only very ancient versions that no one should use.
I got as far as a user LAN. I can't find the word. Like I've got a simple implementation in user LAN, and it runs on Fuse. The next step is to dump it in the kernel, and I ran out of time. That's it. That's where I'm at.
Okay.
And John, there are some discussions ongoing on other possible implementations to replace our in-kernel one, but no progress to be able to report. And Brooks wants to add a comment as well.
I mean, I think from our use in Cherry, 9PFS would do the job for us.
Yes.
I guess I would say that probably should go to want. Is my understanding is everyone's abandoning 9PFS in place of VirtIOFS, so yay.
Didn't we move this one up to have or something?
So we should do port 9.
Yeah, there it is.
So, Brooks, there's a gentleman who's written a VirtIOFS implementation and a whole Virt star testing infrastructure and 2 or 3 other things that is going well. He and Alan are working together, Alan Summers, on that. And I somehow got CC'd, and I'm happy about that because I get to see the progress and I don't have to do any work. What did you? What? Okay, I'll make sure Jessica knows about it. That was a comment from Brooks.
Okay, so this one is now a duplicate, so we could X this one. I think it's supplanted. No, this is the same code. DFR has the cleaned up version of this.
Mike coming over.
Right.
So the situation, there was a code drop from Juniper a long time ago.
Mm-hmm.
Various people made fixes and things for it. I wanted to use it as a root file system, and it really didn't work. So I made a bunch of changes, some of them gratuitous, like renaming things to avoid conflicting with VirtIOFS as a name. And that's the thing which is in review in the have part.
Right.
Since then, more work has happened inside of Juniper, which is not unexpected, and it would be nice to sync up with their changes to make sure that we don't lose something along the way.
I don't know that we need 2 items in the list, though.
No, no. I just need to talk to the Juniper guys.
Okay. But maybe we could add a note or something of sync up with Juniper to the one and have. Okay, we talked about, or Warner talked about VertIOFS. Someone else is working with Alan. Who wants to talk about, I feel like this is more of a Brooks want, or is this even becoming a need? Or is this also the thing that's happening in the GSOC project, right? Okay, so, okay. Is that an in progress thing technically then, sort of? Or we don't want to move it there yet? Not yet. Okay.
I was super energetic. Very much in progress. I don't want to change.
Okay, so Warner was saying that this is in progress in GSOC, and we'll see how that turns out. Streamlined installer, which we talked about yesterday in some context, didn't we? This says you, Ed. So what do you want to say? Is it at some point become a need?
I mean, I think there is definitely a need/want from various downstreams who are consuming FreeBSD and trying to bring new people up on FreeBSD for the first time.
Yep.
I mean, I think there's a lot of different installer projects or different interest in the installer from various places. I think some of this might follow on from what Pierre started with the graphical installer. I mean, it's not related to graphical installer per se, but installer work, I think, as a whole, will be something that we're looking at.
I know Jessica did some changes to make network configuration be more of fewer things that I think get prompted by default or something along those lines. Do we want to split this one up at all? Like, do we want to say something about for a single disk, it should be one click instead of n? I mean, do you want to make this more concrete? Or I guess it's fine if a wish list is a little more vague, but.
Yeah.
Okay, that one's probably. So Doug's right over there.
So Alan tells me this was a holdover from last year.
Where did it go?
Where did it go?
Oh, okay, it's dead.
Okay, so I added support for mounting regular files. Since then, people have asked for sockets and maybe FIFOs, which I haven't done, and don't think there's any problems with doing that. But I was being conservative at the time. I only allow for regular files.
Okay. Did that get merged, by the way?
Yeah, it's in.
Okay,
it was
so that
merged
should
into
be
14 current and backported to 13.
Okay. Well, if someone could tag the commit in there, that would be handy.
Yes. I couldn't give you the commit hash off the top of my head.
Oh no, someone can find it. Git log is a thing, and there's lots of us hacking on the document. Where were we then?
We were at more container support, which I think we can probably change me to DFR there.
We probably want a little more concrete, don't we?
Well, it would be nice to have a co-op student to do stuff. I mean, there's an unbounded amount of work here, and I'd love to have more people get involved in doing stuff. I'd like somebody to start owning the container deport and making it do more things. That's kind of stalled, and I want to not have Podman be the only solution here.
I think it's container D port.
Container D.
Yeah.
Yeah.
Also, do you want to put here like official images or official registry for images and things like that?
Official images, a distribution mechanism that makes sense for those. Whether it's putting them in our GitHub namespace or whether it's running our own registry, I don't mind, as long as we have something.
Okay.
I think we can basically just import Doug's talk from yesterday by reference for the topics here.
Yeah, just put a link.
Yeah.
Do you want to say anything? Okay. Warner says still in progress. Because I won't have time for adding stuff if we need to do. Who wants to talk about Warner wants to talk about this one. Okay, I shouldn't have stopped you. And feel free to add folks. Also, if somebody can keep an eye on like IRC and interrupt me or wave at me if somebody says something, that would be handy.
So there's 3 or 4 things that are on the list. So I'll talk about them just very briefly in order. The bootloader needs to support devmatch in order for us to have a good kernel stuff. And Manu has done that for FTT. We need somebody to do it for PCI. And maybe USB. But you don't need USB to boot usually. Rewrite config in Lua. That's a crazy notion that Kyle and I have had. Our current config is barely adequate most days unless you look at it too hard. If somebody wants to help out with that, that'd be great. Kyle and I don't have a lot of time for that. Merge devmatch and devd. This was one notion to get around the flood of matching issues at boot. Colin has another notion, but I've got devmatch turned into a C++ class and kind of partially integrated with devd, and it looks like Mina is willing to help, but I haven't talked to her about that yet. So this is basically an optimization, particularly at runtime. When you plug a lot of things in, it'll go faster. So
before we go to the next one, on the topic of Lua, something Mark mentioned yesterday during your talk. Do we want an item somewhere? I'm not sure which class you want to put it in, about making Flua more featureful by adding some kind of more libraries, something like the Lua POSIX you mentioned, or something that has more bindings that we ship to make writing things in Lua less painful.
Yeah, I think we want like a FreeBSD namespace in Lua.
Okay.
Yeah, sorry. Basically extending it to support all of like libsys, libc, and in particular, like, yeah, having FreeBSD.sysb system calls, FreeBSD.cb, and on like the rest of libc. I'll put something to this effect.
Okay. Yeah, it came up. It sounded like a good thing. That should be on the list. Excuse me. All right. Do you want to talk about this?
Yeah, I'm quite interested in scheduler things, and I'm currently hands down in it. So I thought that with that line, I think that other people are interested, and I think I saw a commit in the past few weeks about grabbing more information from the cores themselves about how a program performs on them. So I'm not sure. So I guess some other people.
That was Constantine, I think.
Sorry?
Was that Kib, I think, or somebody else? Okay.
I don't think so. I'll have to look it up, but I think that some other people may be interested there.
Carl is interested in it, so.
Just add me to the list of interests.
Sure.
Okay. Actually, I'll ask Mitchell if he wants to talk about this one. He's been writing a lot of man pages and updates to man pages.
Yeah, let's talk about man pages in general.
Well, let's start with this one.
Well, I'll start with the second item here, the audit. So essentially, in the last year or so, I've taken a look at kind of what exists in our Section 9 man pages and like done it up in a little spreadsheet of, what's the last modified date. And, I was able to kind of attack some of the low-hanging fruit and bring a few pages into this millennium, including the intro page, which was really like it was a bad look for that one to have been written as a one-off thing and in like 1996, which is before I was born. So now the intro page is like kind of a map of what exists, and it's like a little bit messy because that's just kind of what we have. But essentially I'd like to kind of publish in some form my investigation into this, just so we know a little bit like what kind of areas are covered by documentation and what's kind of really outdated. And I think the two kind of biggest core pieces of functionality that are really outdated being the scheduler pages are totally obsolete, and the VFS documentation is really big and wide and inconsistently up to date. So a lot of it is like halfway correct, but maybe it's 10 years ago or more. So there's a lot of work needed on those, and they're in the want category because
yeah,
it's
varies.
kernel docs. But I guess in general, I'm interested in this improving this area at especially removing the weeds, so to speak. So if there are particular pages in section 9 that you're wanting or that you have problems with, I'm interested in that kind of feedback.
Okay. Ed, what is your comment about man pages in general, or other man page topics besides 9?
Oh, no, I'm just saying that we can talk about man pages.
Okay. I don't want to talk about the next one. It'll happen someday. It kind of mostly doesn't matter because the things that are under Giant don't matter.
Maybe we should have some documentation about Giant that confirms that.
A Giant said a cosine. I can't say French words. To rename it to something else.
Géant.
What is it? What's the French word for tiny? I don't know.
Yeah, I was actually thinking of having an April Fool's Day post that we've renamed Giant to Tiny. The only thing that's really under Giant that matters is NuBus. Everything else is the TTY driver. And once we get NuBus out from under it, we could just rename Giant to TTY lock.
Yeah, just pretty much. Especially if we could remove the weird semantics too, while we're at it. Okay, maybe someday. I think this is from last year. So I'm going to look at Lee Win to say, do you have any thoughts on this item? Or an update?
As I remember, the current code needs to rebase and cannot apply for the latest current branch. And one blocking issue is that there is still no suitable and license compatible fonts available. So that would be the major issue. And the last student, he's purchasing a PhD later this year, but there is another one who seems interested in this and might pick up after after reading the code, understand it better. So yeah, I would say it's still a work in progress.
Okay. Is anybody else interested in TARFS, or is it only Warner interested in TARFS? I feel like several people are interested in TARFS.
I feel like it can't be only Warner.
Yeah.
Your name is on here, Warner, for TARFS's
Yes.
root.
Yeah, because we don't need another file system to do an NRD. I have it on here because we don't need another file system to do an NRD. And Linux has done its NetRD as a CPIO archive for 30 years now. So it's just something that I would like.
Okay.
That's why it's under want and not need or have. I also put Dez's name next to it. There's not an update, I guess.
Let's see.
Oh, there we go.
Now it is. I'm going to look at Alan about this next one. Oh, I'm going to look at Alan and Doug together and see if they have anything to say about overlay FS.
So the original requirement we're looking at here is specific to TARFS. So
Okay.
if you're using TARFS to provide packages or additional capabilities on an appliance, being able to mount a whole bunch of TARFSs onto like user bin and have all of the stuff show up. So many layers of TARFSs with one writable UFS on top. So not specifically overlay FS, but a way to overlay a bunch of TARFSs with one UFS for an appliance or whatever. That was our use case, but we were interested if people had more general use cases of how we could try to solve them all one way instead of ending up with 3 different ways of doing it.
So my use case is, so I use ZFS for building container, or rendering container images, like applying all the layers. This is not great if you don't have ZFS on your machine, because the only alternative driver is just doing wholesale copies, and it's really slow. I think Union FS is going to solve my problem, but this is potentially a viable approach as well.
Okay.
We have a comment on the other side of the room here, John.
Go for it.
Yeah, I wonder how would we handle the whiteout files if we want to use TARFS in the container scenario, because container overlay is not just a bunch of CPR archive, it's also the whiteout files. And they're like whiteout files to white out one file, but they're also whiteout files to white out entire directory. And do we want to follow the OCI standard in terms of like handling?
Here, run the mic again. We do need 2 mics next year.
Okay, so yeah, whiteout is an important thing. I think the Linux overlay FS driver has, so you've got the lower data set, the upper data set, and I think they have a third data set where they store, where I believe they might store the metadata, but I might have this all wrong because I haven't read the code. But basically they separate the whiteout from the underlying file system, which is different from Union FS, which relies on being able to mark a file as whiteout. We need some solution for it. It needs to work efficiently for deleting directories as well. I don't know where Union FS is for now.
Yeah, I'm not sure what they do for directory specifically, but for general files to wipe them out, the way they seem to handle it on Linux is they actually create a device file with a major minor number of 0, and that magically means whiteout. That's, I think, a different one. And the advantage to that mechanism is that the file system doesn't have to support a specific like inode type of whiteout, like UFS does, but ZFS does not. And so that maybe is a way forward, but I don't know what you do for directories in that case.
So yes, on Linux, you're right. It's currently it's a special device file standing for whiteouts. For directories, they have they use extended attributes, and they have an opaque extended attribute for that. And so for yeah, it's true that for UFS there is special support. I think I was kind of just starting discussion with Rob on how to implement that for ZFS, for example. I don't know if it's in your use case, if it's something that you want to require or you want it to work without that, or.
I need to be able to build an image layer that deletes a file in the parent layer and have it work. How it works is not as important.
Okay, So the next ones are definitely some fairy dust. And Brooks is staring intently at his screen. Unless anybody else wants to talk about Rust in somewhere in the system.
I mean, I think at the moment there's not a lot of broad interest. We don't have a specific application. If we had one, we should do something. I continue to worry that we're going to end up in a state where some kernel framework we have to use gets written in Rust, and then suddenly we're going to have a panic. So it'd be nice if someone chased something, but I don't think there's any specific target or any specific deadline.
I think this is one thing I think this sort of venue is really useful for, though, is asking for feedback from our downstream consumers as well. And so definitely interested in knowing what sort of use of Rust in kernel or user land people building products derived from FreeBSD or see a need for it, and when.
HardinBSD definitely is interested in supporting Rust at the very least in the user land, but would love also support in the kernel. We would definitely be your guinea pigs for that. Our community would be. And we would probably port some of our own applications to Rust as well.
Run. maybe we'll trade in a little bit.
There's a huge amount of support for Rust on Amazon and EC2 as well as services. So I mean, we see this tremendously. There's a lot of transition for projects from like EFS transition from S-tunnel to to an EFS proxy that's written in Rust, and that is going to land somewhere and need to be recompiled as a for a package. It's an open source project. Should be in the available directly for users, and lots of projects are going in that direction, moving away from things.
Yeah. In particular, yeah.
Yes. Well, no, I think I might have misunderstood, but I think that there's just generally there's a definite need for that, and I think that it's going to be more and more of the component parts that you're going to see coming in from, say, Annapurna Labs, things like that. Right?
Yeah, what I'm expecting is that, things like cluster service management and stuff. Those are things we already install as packages. So like the fact that they moved to Rust doesn't change a lot for us, which is good. The question is, when do we get something that needs to be in the base system or that we want to be in the base system? And now we have to do a bunch of work to integrate Rust. And that's where I'm hoping somebody like HardinBSD will blaze that trail so we can figure out how it's going to work. Because, I think I haven't been following super closely, but like in the Linux community, there was some big excitement, and then there was some big, that's complicated. And we need to start understanding where those spots are in the kernel space and whatnot.
Yeah, and I'm living through that immediately, which is that we have a lot of these tools, but then determining where the actual support is, which versions, which ones are in the system itself. Those are the greater concerns and complications. So definitely want to keep that conversation alive.
Yeah.
Yeah, the biggest issue, like just on a technical standpoint, is that so even though Rust has a concept called additions, which are more akin to your C or C++, your standards, so to speak, even though there is really one big Rust toolchain implementation out there, even they just release, they release too often, at least for our base system cadence. So it's like, just because of that, there's gonna have to be a lot of reckoning outside of us, outside of really any operating system community. Like, it really has to be a reckoning within the greater Rust community as to, like, hey, like, there are some operating system, integration thoughts, but this rapid release thing is just not going to cut it. It's especially if there's, like, if you got to support, longer, do some more longer term support sort of deals, like how we kind of do things with our releases. I'm sure there are other operating system vendors and projects out there that have those considerations. So, yeah, I mean, we could probably, I think at this rate, or at this point, if we're going to really make any inroads on something like this, we would have to just integrate ourselves within the greater Rust community and just figure out, just like kind of make it known that this rapid release, that they're going to have to figure out something other than a rapid release, really.
Okay. So next, there's more interest in netlink things. Alan, do you want to say anything here? Or Rob?
So right now, for fault management and just notifications about things that happen in ZFS, on FreeBSD, that those events get fed through devd and then consumed by ZFSD, whereas on Linux, they have Z, or the ZFS event daemon, which is a very, very minimal port of what Solaris did. And so both of those are very different. And for example, when we added the ability for you to configure, if you get more than this many slow IOs from a disk, let's replace it with a spare so you don't drag the performance of your whole pool down. We had to do that for Z, and then separately, Alan Summers and somebody else, Alec Pinchek, did the implementation of ZFSD. And so every time we add something, we have to do it in 2 different code bases that are not even written in the same language. And that's really annoying. And just kind of relatedly to BAP's next item, devd, there's only one thing can consume that socket. With the netlink system, you can have multiple consumers that can apply filters of what events they would like to see. And so that would allow much richer event management, and just people, in addition to using ZFSD or whatever we replace it with, also be able to consume the events in a different way for their monitoring system or whatever. And so we'll be doing this work mostly on the Linux side, but we will also make it, the fact that we write it once and it'll work on FreeBSD and Linux will be a big win there, I think. And make sure that the fault management on FreeBSD keeps up for free.
Well, I think devd's model said it assumes the multiplex happens in user space rather than the kernel. Is that a fair statement, Warner? That the design was that the kernel would still emit one stream, and it was up to user space to kind of mux it to multiple clients? Okay. Okay, well, in particular, having one place instead of 2. I'm looking at Alan because Mina's not here. But you could also say, I don't know. I don't have more thoughts.
Many years ago, I started working on converting login.conf to UCL, mostly because at the time I was overriding a few of the defaults, and it made it annoying to keep the file up to date across all the versions of FreeBSD that we were deploying. And so being able to have an include file that had my local modifications was an advantage. So I wrote a patch. You can tell from the review number that was like 7 or 8 years ago now. Never quite got finished. It'd be great if someone finished it. And if we could adopt UCL for the config files of like everything in /etc really. Just because we gain the ability to have those include directives and so on. And the fact that right now we do, like, I also had a diff to do this for a new syslog, but that got done differently. And while it's great to have them, the fact that it's kind of piecemeal really makes it harder to deal with. I just want to configure my whole system one way.
Does anybody have any thoughts about the next item, which is libxo for more tools, networking tools in particular? Do we want to? In the past, we've annotated items when we didn't get an update, like with a double exclamation point or something. I wonder if we want to do that again. Okay.
So ifconfig. At the moment, to get IP addresses for containers in cryo particularly, I'm parsing the output from ifconfig. This is brittle.
Yes.
But I could get this. I put another item at the end about netlink into a jail, and that would get me what I need as well. So, but yeah, ifconfig is the standout here, and I don't know how you go about converting that to libxo. It's too wild.
In some cases, I've wondered if, like, my thoughts on PCI-conf, for example, are that I think for structured data, I would think that for things that are structured, sometimes you want to just have an entirely different path that is just generating structured data in a structured form, and instead of trying to interleave it with the human readable sometimes. Uh-oh, Warner is coming down.
No reason yet.
Oh, no. Wow, that's so... that's not at all intimidating. All right. I don't think either of these individuals are here either. If anybody sees anything pop up on IRC, let me know, but I'll keep going. I feel like GVE landed in the tree. Is this true?
GVE is in the tree. Liwen, do you want to comment on this since your name's on it? The item here says ARM64 support for GVE.
Which I feel like is in the tree.
Yeah, as Ed says, MD GVE is in a tree, and but currently only works for MD64, not ARM64.
Okay.
But this is probably more bug fixing than any major function.
Well, but yeah, but yes, but not something that exists yet.
Right.
Okay, so we got 3 more here. I thought I did more. Remove Mac label limitations. Whoa, why did it scroll so much? Might delete some things. Oh, there's Doug's new one. Not like access to a gel VNet. Oh, just want to delete the one below this, I guess. This one was an Allen one, and then your name got taken off. You and Des.
Accidentally, maybe?
So when we were reviewing Baptiste's new MacDo stuff, it came up that when we've done other stuff with Mac in the past, the concept of labels in Mac are statically allocated specifically to avoid dynamically allocating stuff at runtime. But that means that you have a very limited number of them. I think like 4. Yeah, there's 4. And so even if you just load and unload Mac modules a couple of times, you're now out, and your only solution is to reboot if you want to change the configuration. Is it possible to use something like what Bap did there with Pavel's OSD framework to allocate the memory but tied to a specific object so that it would have its lifetime tied to the module it's associated with to solve these problems? And if we're going to continue to do more and more things with the Mac framework, which I think we should, can we solve some of these fundamental limitations to make it much easier to have configuration and state live, but in a way that isn't harmful to performance?
Okay. Maybe do you want to restore the commentary? Because I think what you had there was before.
Several things that just got lost.
My laptop was that was probably me. Sorry. How do I undo?
I don't know. Well, the one benefit is that this was streamed, or is streamed. So somewhere on YouTube, there's a screenshot right before it all went wonky. It does. It's not. It's only, but so granular.
Roll back and then.
PID namespaces for jails.
PID namespaces for jails. Okay.
And import HTTPCD and things. Oh,
Yeah.
okay.
Ah, thank you.
There you go.
Okay. All right. Does anyone want to talk about the PID namespaces for jails then? Pavel does. Which other namespaces?
Not sure why me, but so yeah. So currently, with vimage, we can have like separate network stacks per jail. But for other namespaces like PID namespace or mount namespace or others, everything is shared between the host and the jails. So so apart from like security problems, there is also a problem with scalability. So for example, we have a system which runs over 100 jails with each having our product, and we end up in something like 13,000 processes, and then the global locks that protect process list are really congested, and everything slows down heavily. So there is like this limit, like 13,000 processes on this particular machine. So being able to hide all those PIDs on separate lists per jail lists would of course help with scalability, but would also allow us to have init in each jail. But then we need to figure out, I think it also will help with like scheduling and resource management. So it doesn't matter if the jail have 1,000 processes or 2 processes inside, we could try to apply the same amount of CPU time for each jail. But of course that if we still want to be able to address individual processes inside the jail from outside of the jail, which people like Doug wants to do, then we need some work to be able to do that. So for example, we need a version of kill system call where you can provide a jail ID and PID inside this jail, or actually you should also be able to like send a signal to nested jail, so that's even more complicated. So stuff like that. But yeah, that's something that would be really nice to have.
Okay, so I have one must-have here. I need to be able to wait PID for the process that I started within the jail. Wait PID. Yeah. So the way OCI containers lifetimes work is they're bound to the lifetime of the first process that was put into the container, right? And it's not something we can do to change this model. We can't tell the Linux world that OCI is wrong. You have to start again. That's not going to happen. So we have to be able to work with that. And right now, because we don't have jail PID namespaces, they're just a redacted view of the host. This all works. I know what the container PID is. I can get sigchild signals for it. I can do wait PID on it, and all of the tools work. I didn't have to change a thing. I need that to be preserved in some way. And nice to have would be to be able to poke at individual processes within the jail, like as a sysadmin, that thing's gone wrong and want to kill it. But the first part is non-optional for me.
So in particular, it sounds like, just as Pavel's mentioning, kill and some other things, having a way where you take a namespace ID as well, like a tuple, effectively, you might have to have a way to wait on a tuple.
I need a unique numeric identifier for the container itself, which is right now it's the container PID, and that's how it works everywhere else.
You can't use the jail ID?
I can't wait for jails.
Oh, that probably could be fixed.
I guess so.
Especially with wait ID,
There's a lot of assumptions in the code base that you can take the container PID and test it. Like if I kill 0 to see whether it's still there.
Yeah.
Or wait on it to get its exit code. I need to be able to get exit codes from the container process as it exits, things like that.
They're starting work on that.
So I'm going to talk about Linux. The way Linux does PID namespaces, and this kind of breaks the thing that Pavel wants, is that if you have a container inside a PID namespace, within the namespace, within the container, you see a local view like PID1 or whatever. But inside the kernel, each process has 2 PIDs, or 2 or more PIDs. It has the container PID, it has the host PID. If it's nested, you have the child nesting PID, the middle PID, and the host PID. I think you can have up to 32 levels, right? And so there's always a host PID for everything in the container, and that's the way they do things.
Did you want to say something about this topic? Sorry.
Well, first, just a little comment on that last bit. So much for not exhausting the PID size. But I've got some work starting on jail descriptors, which means that, yes, you could wait on a jail. I would also like to see a slight change in process descriptors. Right now, the only way to get a process descriptor is to fork into one, and when you close it, it dies. I'd like to see more of a view process descriptor, where you can get a descriptor for a process, and then you can wait on it and things like that, without having to own the process and kill it. Both of those, went in a descriptor way, and then, yes, you can pass descriptors anywhere you want between processes and controlling daemons and the like. Okay.
So yeah, if we go too far away from this big model,
Yeah.
Yeah. All I'm saying is that this assumption is built into the entire ecosystem of tool chains, and we could probably make this work, but it would be a lot of change for upstream, and there'd be a lot of pushback from upstream about making this core part of their system more difficult for them to maintain. So.
I think we lost a new line or something. Okay. Woohoo. All right. So we've got a half hour left. So I think, well, SDG is a one, but Simon's not here to say what it is. But yeah. So let's move on to burning things down. Are there? I added a bunch. Okay. Okay. Last one. So then we got to burn things.
Yeah. So right now we we've got a -J argument to a lot of the tools so that we can do things to a jail's VNet from outside. And the way that works is it like say if config will fork, jail attach, and do the operation. If there's nothing running in the jail, that's safe, I guess. But it's a bit clumsy. The way that things work, if you've got netlink, you can, like with netlink and network namespaces, you can get a netlink socket inside the network namespace, then do netlink things to do stuff, and that that makes the initial configuration easier and slightly more efficient, but it allows for safe access to metrics. So I can get socket metrics without forking, without pushing an instance of netstat into the jail and getting the stats, because in a malicious jail could then attack. I think this is far-fetched, but it's a possibility.
Okay. So I guess the first pass is, are there things that on the list of things to burn down that we don't want to burn down? I'm assuming if it's otherwise, we'll just say that yes, we're going to burn it down unless you have a question. So
yeah, we don't need to get
too technical.
Each of these, I think,
so there is a question here. So we have this thing that we're kind of thinking of doing of 32-bit platforms and 15 mostly going away. And I guess this is not really about i386, but of the platforms we're planning to deprecate for 15, when do we want to do the actual kind of axe chopping? So I will give my opinion maybe and then open it from there. Because we still have to keep the darn things around in 14, I'm kind of inclined to wait till we get pretty close to 15.0 before we actually start felling trees, because then it gets harder to backport fixes perhaps. But I'm open to other thoughts.
Okay. I have thoughts.
No, I wouldn't be surprised if you didn't.
I'll keep it brief though, maybe. ARMv6 we should kill right away. i386 kernel later's fine. 16-bit PowerPC we should kill right away.
16-bit.
Sorry, 32-bit. PS3 we should kill right away, unless we're also going to kill PowerPC entirely in this release. I've linked a bug there that has been going on for months. When I tried to do the PS3 stuff, everybody has a PS3 in the closet that used to run FreeBSD, but maybe I'll get it out and test it for you if you ask nice. That's the level of support for that. So I'm thinking, I'd like to say maybe we just kill it all in 15.
I guess I will comment. I completely broke PowerPC, all of them, for 3 weeks. Like nothing worked because you couldn't make system calls.
I'll mention that I use FireWire for kernel debugging still.
Yeah, so. There's a talk later about how to not do that anymore.
So we won't kill FireWire yet, maybe next year, before 15.
I would say that nowadays, my preference for something like the access you get with FireWire would be either USB 3 debug, or even better, in my opinion, is using VMs, because you can run a GDB stub on the hypervisor itself, and you can break and control a kernel, even one that doesn't want to be cooperative. So even if you're spinning with interrupts disabled, you can still break and poke at the darn thing if you're using a GDB stub that's in the hypervisor itself as opposed to in the guest OS. And that level of control you can't get over FireWire. FireWire just gives you kind of a really nice memory dump, which you can also get from a hypervisor pretty easy. Oh, it also works with QEMU if you're doing cross debug. That's not super fast, but it does work.
But we do need something for actual physical hardware debug.
Yeah.
And I think the answer is for us to invest in USB debug as the replacement for the cases where FireWire actually provides something you can't do through VMs today. That's my suspicion.
I would agree with that. In particular, it seems like USB 3 debug is not crippled universally the way it was on USB 2. In regards to PowerPC 64, my one thought about that is there is some open reviews I'm aware of from folks at Raptor Engineering, and I want to ask them who they're doing it for. Basically.
Asking the question, I don't know what the answer is.
But if you,
I will say that like PowerPC 64 has caught some things that until we get cherry in the tree, we wouldn't have caught. So like it is giving us a bit of value. I worry it is a bit too. It's not as weird as Spark or MIPS was, but it's got some places where it's gratuitously weird, and I feel like the people who care about it need to like fix the fact that there are PowerPC specific conditionals in libc's makefile. Like that needs to go away, or the platform needs to go away because it required more thought than it has users.
Just this bug report on the right though. That's referring to 32-bit PowerPC platform, isn't it?
No, 64-bit, I thought.
Oh, really? PowerMac G5 is.
G5 was 64-bit.
Oh, okay.
G4 was 32. That was like the Xserve servers you could get and so forth. Well,
It's hard to see this as good justification. It runs pretty well in Power 9. Yeah, what's been reported.
yeah, well, this may not be a good justification. For hardware that's real, well, so, so I will say, for example, we've had a recent thread about hardware for PowerPC that the current hardware that we have access to has not booted successfully, like in the cluster for, I don't know if it's an order of months or years. Definitely many months that it panics on boot and doesn't work. That the two machines that we have is my understanding. And so our cluster admin team is nervous about adopting new hardware if the existing hardware is something that does not reliably work and they can't get anybody to fix for months on end. That kind of meets the bar of not feeling very well supported.
That's fair. But meanwhile, so when I say that Justin is using a Raptor, one of the power mods, supposedly with this, so this bug report that I'm reading, just like thumbing through, says my only G5 that ran FreeBSD died back in 2018, so I'm being Justin, unable to do anything significant for it.
Yeah, I mean, I don't know that this alone would mean you would, like, G5 is such old hardware, I don't care. Like, FreeBSD does not run, well, our target audience is not 20-year-old hardware. We're not a computer museum OS.
Commented last year saying, I've been using only the Power 9.
Right, I mean, it's like, I would say you could just close this bug and it doesn't mean, it has no bearing on whether or not we continue to support the architecture because it's just so old it doesn't matter. It's like saying, does the fact that someone has a laptop from 1996 that FreeBSD i36 panics on maybe remove the i36 port? Well, no, because it's just too old. I'm not disagreeing with you. I think that this is not relevant to the discussion, but things that are relevant to the discussion might be that we have more recent hardware in the cluster that we can't get anyone to help cluster admins fix so that it actually boots. Or if you do look at the survey data, if you added up all the PowerPC users together, you'd have to multiply them by a couple times to get to the next architecture of both 32 and 64-bit. So like, there are some other data points. This one may not be the most high quality signal.
I think one point is that people who use or particularly care about PowerPC on FreeBSD on PowerPC on Power 64 need to make the community aware of their use and their willingness to support it.
Yes. This is kind of a placeholder. Is there something actionable you intend to do here? Is this bigger than, I mean, is this ARM v7 SoC review? Is that what this is about?
Yeah, it's like things like.
Here, wait for the mic. I'm looking at Warner, by the way, for stream people.
The SoC review that Mono and I put on here last time was to just make sure that the SoCs that we have kernels for actually work. And this would be like retiring things like the Texas Instruments support, with some of this Texas Instruments support, which doesn't work, like the old Panda boards just don't work at all anymore, because the DTS in Linux is a moving target and nobody's kept up, for example. So that it's to review everything we have and to kill it. This is mostly Mono's been pretty good about doing that every 6 months or so anyway. So
Okay. Do we still have FTPD in the tree?
Yes, or days at most.
So Alan says yes for days at most. So I don't know if Des is active on IRC. Oh, well, actually, I don't know that this is actually assigned to him. There's like 2 or 3 places in the tree where we still have Des encryption, and it's for like really ancient crap, like some weird Kerberos stuff, or it's also the SMBFS, right? I think that's one of the last 2 consumers, maybe the only in-kernel consumer of this now. Des. That was worth the price of admission. SynMail. Baptista's not here for such a bold statement. All right, that's not from last year. I'm going to look at Warner for the next one.
Sure.
And actually, I could also, maybe not for 15, but at some point, bias boot on AMD 64 might be in danger of being Dodo.
Yeah, so bootloader 4th support, I think we can kill, but I haven't confirmed that with Juniper. They were the last known user. And BIOS boot is not for 15. Too many people use it in too many weird places, even though it's very old. There's some VM environments that make it difficult to use UEFI. They're disappearing, but I don't think they'll be gone in a year and a half.
Makes me sad, but okay.
It makes me sad too, but you know, we live in an imperfect world.
Okay.
But I think now is the time to have that discussion and have notices in man pages.
Yeah, I'm wondering about, at what point should we have something in the release notes saying, you're running with scissors if you continue to do bias booting. At some point you'll trip, or something like that.
Like in particular, if someone installs a new FreeBSD installation today with bias boot, that's something that you should be aware of.
Should we throw up a dialog box in the installer if you decide that you want to do that instead of EFI? That's a good question.
Yeah, I mean, like the dialog box idea for something like that, especially if you're on a machine that does support UEFI, like that does sound like good. Yeah, because I think there might be a good amount of folks who just might be unaware that their machine, you know, like for some folks who have been using x86 for quite a long time, they might not be the most aware about even to this day about the presence of UEFI. But the other issue is that even like relatively new machines, I would say even from like 10 years ago, like even server hardware, they don't even support UE. Like I have a donated HP ProLiant that doesn't have UEFI at all, and that was from like 10 years ago somehow. But also even machines from like 10 years ago that did support UEFI, the UEFI was actually not even implemented properly enough, such that like not implemented properly as in like it has the EFI like file literally has to be named bootx64.efi or else it will not boot, sort of deal. There was a lot of copy paste, crappy implementation last decade, so it's just something to think about, like, because especially since it was pretty crappy at least last decade, and it might still be crappy now.
And do think about what hypervisors and cloud providers might still be stuck in BIOS land.
Yeah. I realize, I mean, I have one of the desktops that's whatever, not Sandy Bridge, the next one that has EFI, but FreeBSD won't boot happily with it in the installer. I think in the installer, by the way, we can only tell which way you booted, not what way you could have booted. Like, we don't have a good way to say, can you do EFI? We just know which way did you come in. So I definitely think we could whine that if you came in via EFI and then you asked to install with a BIOS, we should probably kick you over the head pretty hard, or something like that. But it's like how we used to have the dangerously dedicated thing. Many of you are too young to know that existed. Some of you may not have been born yet, even. Okay, so we need to think about a strategy for at least starting to warn people when we can find places where it makes sense to warn, I think. Server component, yellow pages, or NIS is the newer spelling from not the last, they're both in the old millennia. I don't know, does DevOnline or anybody else care about these things? I definitely feel like this is the server bits of this could definitely live in ports easily. I believe. I mean, LDAP lives in ports. I don't know why we can't have the NIST server live in ports. Someone could maybe check to see if these are actually killed yet, or if they're still open. Ah! Okay. Warner, do you still want to kill this cam target driver?
I'd like to. I don't know anybody that's using it. I don't know anybody that's using it, but I also want to double check with Mav to make sure that nobody's using it. And Ken, Mav is here.
He's getting a thumbs down.
Kill it? Kill it with fire? Okay, yeah. Yes, I still do. I don't think there'll be any pushback. I think we're good to go.
That's
no,
different.
He's using CTL.
Yes, that's different. That's completely different. That's completely different.
One of the changes I lost was put in parentheses, no, not CTL.
Yeah.
But yeah, nobody's used this in a long time. I think we can just delete it. And with a post to Arch that says, hey, I'm going to delete it.
Okay, yep. Fingerd? I probably could, I don't care. You definitely don't expose it to the internet.
Fingerd fits on your screen.
Yeah.
Because it execs finger. You should probably kill it because of that.
Could it not just be an inetd wrapper thing? I don't know. I have no strong opinions. I only use it over local anyway, like SSH to a box and run finger. Yes.
Fingerd is spelled SSH.
Free fall finger, that's what I use all the time. I will probably still kill these things. I did figure out that 3DFX does have a PCI attachment, but I think I don't care. If you remember this hardware, I think, well, yeah.
I think I'm probably the only person that ever used this driver, and I haven't used it for more than 20 years, so I think it can die.
I was cleaning up I had a recent change where I moved more stuff to the x86 notes out of AMD 64 where I discovered that we have a 3DFX like Linux thing that is only i386 only and not enabled for AMD 64 or even for Linux 32. Like it's hacky. No one's using this thing. Syscons. Ed. What do we? Yeah. Such enthusiasm.
It gets pushback and some legitimate. It gets pushback and some legitimate commentary every time
And the NVIDIA driver needs a VT backend. That would also help.
Yeah, yeah. There
Shouldn't be hard.
are a small number of VT improvements that need to be made for full parity with syscons.
Say what? They actually, so a want should be a VT backend for NVIDIA drivers, certainly. That's definitely a want.
Yeah.
I mean, I would hack on it maybe if I, at some point. I've thought about it. But yeah, we should add a want for that. So you said PowerPC. Does PowerPC missing the VT backend? Which is easier to remove? Which is easier to do? RM PowerPC or write a VT backend?
PowerPC problem is that VT doesn't work on a small number of PowerPC machines, so that's a workaround to use.
Oh, okay.
You might want to say that.
Okay. They don't have like the OF open firmware frame buffer or something? Doesn't that have a VT binding? Oh, whatever. Okay. Even better. Various drivers. So Brooks, are you still interested in looking at more Ethernet drivers than before?
I think it's probably worth doing a sweep. I don't know if I'll get distracted and do it or not. Someone should do a sweep. It'd be nice if we had better statistics on what was being used.
Yeah, data would be good. I'm supposed to.
There's a bunch more junk in there that should go away at some point, but I haven't like gone and checked to see if there's, PCI only devices, not PCIe.
Yeah, I mean I want to kill kind of anything that's not that's ECU that's not really just LPC. That should definitely be burned in a fire. Then Warner is on the hook for CAM drivers, some of whom have better names than others. I don't know. All these names are terrible.
Yeah, all the names are terrible, but we need to do a review and look at the old ones, particularly the ones that still touch Giant. Yeah,
or all those need to. I think those are all mostly ancient. I'd like to kill all the ones that have blobs.
yeah, kill the ones with blobs.
They're not generic.
Good. Sys and MVS are really old, probably no longer relevant, but posting to Arch will find that out, or Mav will throw something at me.
I'm looking. I'm waiting.
They are not exactly driver are relatively not so old compared to some HPT, so I don't know whether they.
Okay. Yeah.
Okay.
So I just want to. Yeah.
AKVS hardware it's ugly, while SIS it's slow, but otherwise it's working.
Okay. So I just want to look at them to see if there's any we can eliminate as well. PMS was basically a commit, and
It was a drive-by and abandonware, and it's horrible.
Exactly. So
I'll say it. Yeah, it's aptly named, sort of something. I think this is. Colin's he's checking on the slide, so he's not here. But I think I think these are still valid. ACPI safe timer is like a fallback that only matters on i386. So when i386 goes, it'll go. There were some very old chipsets that were the little time counter for the P2X4 chipset was kind of broken, so we had to have a careful version. We talked about 32-bit platforms. This really is merged with i386 kernel, so those are the same thing. Yeah, well, I think ARMv6 is we plan to do sooner. ARMv7 will stay longer. In fact, ARMv7 we plan to keep as the longest 32-bit platform. It'll do one more release than everybody else. Because I think v6 is like a single thing, right? It's just Raspberry Pi 0 or something.
Raspberry Pi original and Raspberry Pi 0 are the only ones that. And our Pi 0 support sucks.
Oh, make sure you keep getting, just give Warner the mic, especially the next one. How much of this, because I think we still have a lot of CPU type soft stuff still floating around.
We do.
It should all die in a fire.
Yeah, we still can build for this, but nobody wants. We still have support in the tree to allegedly build for this. but nobody's going to use it. The one project at Juniper that was going to use it isn't. So I think
Going to
we
revive
can
a
just kill it.
terminal room tradition tonight. Oh, it's worse.
This is so ARM had this weird thing where it would do floating point stuff, but had an API that passed it in integer.
Yeah,
registers.
it's like soft float, but you still use the registers for your calling convention.
It's hard float.
Andy's saying poor gas.
Hard
lat match.
No, it's hard float instructions, but a integer register API.
Oh, never mind. So I had it backwards. Oh, okay.
See, I can make it worse.
And we have all these glorious. That's not the right word.
I think we removed the LD.SO support.
I think the LD config crap is gone.
I think I killed that, but we still can build for it.
Yeah, I think the CPU type checks are still around. And there's some of that is soft, and there's kind of a weird overlap. Well, we got rid of RISC-V soft float that also got, and MIPS, and that helps also alleviate.
I think we can kill the power stuff because it's 32-bit. And we're not planning on having any 32-bit compatibility for power.
It's there. FreeBSD 32 is there for PowerPC 64. It compiled.
We need the support in the kernel, but we're not going to build PowerPC 32-bit libc directly, just with the compat 32. Basically, so it can do -M32 support.
Right. Yeah.
And that M32 support doesn't support all the weird float.
Okay. All right. So that's what. Okay. Sounds good. So Mark is. I think these are new. Oh, these are kind of interesting. The first one is more boring. So, do we need to still swap out kernel stacks because they're tiny, and we get all sorts of fun issues because while you're asleep, things on your stack can go away.
Yeah.
If you put them in a linked list and then do that, and then lots of fun happens.
So as a memory saving measure under load, we can swap out kernel stacks, and that has implications all over the kernel. And we're saving, when we swap out a kernel stack, we free up 16 kilobytes, and it's just not very much. And
then we have to back it later, and then we have weird edge cases that when we have to go find the backing store, and we had pinned the thread, and it was in one domain, but now that domain is empty, so now we've got to go find crap in another one, and oh, well, okay.
Exactly. So that mechanism is very old. There's even a, if you want, there's a syscontrol you can enable, and the kernel will just do it for idle processes. It'll just automatically swap out your stack.
Is that a panic implementation?
Sorry?
Is that a panic implementation?
I mean, I don't know. It just feels like a very old and probably not very important mechanism, given how much complexity and how many bugs it seems to be involved in. And I would like to just remove it. So I'm wondering if anyone strenuously disagrees with that.
Kirk wants to talk.
Oh.
He probably used a machine where it did matter.
So that got put in back in the VAX days because it was really critical to be able to recover that memory when there was a lot of processes running. And even back then, it took us months to get to the point where we got the kernel stable again. And as much more complicated as things have gotten today, I can't believe that it's gotten any easier to deal with. And I agree, it just is utterly unnecessary today, so get rid of it and save all that code.
It's like, why not swap out other things?
Gas.
Swapping out a Reddit table. Like, I don't know.
Yeah, the amount of memory you'll get back by getting rid of all that code is probably more than the amount of the stack.
All right, I think that's a win.
Yeah, let's have some plus ones.
Yes, we get like, can we get like plus 1,000 or something? I don't know. This is an interesting one. So do you mean that if you take out options SMP, you get an error, like hash error or something?
Something like that. Basically saying that if you remove SMP from your kernel, either that means nothing in the sense that like an AMD64 kernel is intrinsically SMP, like there's no if-def code that changes.
Okay.
Like any mock-dep. The reason I want to do this is we have a whole separate set of TLB invalidation implementations for not SNMP kernels, and they were broken with PCIDs for a long time, and nobody noticed, and I wasted like 2 days only to discover that.
That's interesting. We used to do this. We used to omit the lock prefix for atomics.
I think we
we still do. I thought we got rid of that to just screw it in the kernel. We just do it always. And I think certainly in userland we do it always. But I thought we just said we do it always because we used to. On i386 at least, and maybe it was only on i386, we would actually make kernel modules call a function for every atomic op so we could hide the lock or not. And I was pretty sure the cost of the function call was worse than if we had just used lock all the time. And maybe it's just that for KLD module we do it always, and maybe in a UP kernel we still omit it, but it's kind of not worth doing.
It's something like that.
Yeah.
I checked this like last year because that's when I started getting frustrated by this stuff. But it's like, yeah, it's effectively a micro-optimization that I don't think people are using because, again, TLB invalidation was broken for a while, and that caused all sorts of interesting problems. And yeah, so I guess I'm wondering, does anyone, compile AMD64 with no options SMP? Like maybe if you're really interested in micro-optimizing your single vCPU VM or something, I don't know.
Have a config so that occasionally when I build, it will get built as part of a universe, so I'll know if I broke it.
Yeah.
That's all I have. I spent a lot of blood, sweat, and tears for 5.2 so that we could have an SMP kernel boot on UP so we could get one.
Yeah. But these days, I mean, I don't know.
The only reason you have it is to make sure it's still built.
Yeah.
I think that's telling.
I don't think it gets used, and it's a whole bunch of really complicated like the TLB, the PMAP code just gets more complicated as a result. And that code is already way too big and complicated. So
Does Colin do any UP for his firecracker stuff?
But
it should say
he's working on this talk. I think it still doesn't matter. I
mean, I can check very quickly.
He's in IRC, so he's listening to us.
Okay. I bet though that his VMs still have probably more than one CPU, or at least want the ability.
It still has SPU.
Yeah, and firecracker. Yeah, that doesn't surprise me. Now the question is, are there other architectures for which the same thing is true?
What? Probably not so much. I think there's probably still single.
Okay.
I think it is unwise for us to have whole duplicated blocks of code under if-def, with one case being one that's never used or tested, really. So I think, whether or not we completely remove the option or make it not disallowed to build without it, I think it's definitely fair to eliminate like duplicated code that provides an optimization for UP that we don't use or that we never actually test.
Might be polite to put in an error.
Oh yeah, no, I'll make it an error.
So let's see, what time is it?
We have one more comment over here.
So what are we supposed to? We're supposed to stop at 3. Is that right? Yeah. Oh, okay. All right, last one.
Well, I was just wondering if Ed could expand on why we'd ever want to keep building. Like, why do we still want to keep building non-SMP kernels, and what would maintaining the SMP option buy us if we're going to reduce or eliminate any optimizations for it?
So I think Mark's question is under like sys AMD64, removing if-defs, but there's some things that are in like syskern, and there are some things that are in other architectures.
Or like that option generally is like, okay, we can do something slightly simpler because we can assume one CPU.
Yeah.
I guess the question is that
I'm even thinking of many cases, some of the things would fall out by the fact that your like max CPU becomes 1, and so many of them devolve to like an array of 1 entry and so forth. So even a lot of the ones that are machine independent may not make a lot of sense to keep anymore. like the per CPU code, right? All those arrays are sized by max CPU, and so in a non-SMP kernel that becomes 1. So it really, many of those I think are even kind of gone. Maybe it's the sysinets. We conditionally invoke some sysinets that are supposed to spin up the APs and whatnot. But that could just be a stub function in the MD layer if we did.
Actually, well, yeah, no, having a config which says I'm only ever going to have one CPU just to reduce the sizes of those arrays might be worthwhile. I don't know how much memory saving you'll really get out of that, but there's a bunch of global arrays, although we fixed some of that stuff already.
No, we can't. Max CPUs is in our ioctl APIs.
Well, the CPU set size is in our APIs. That's what's,
Yeah.
and in general, we've tried to fix many of those things, the system calls to kind of cope with the fact that sizes might differ at runtime.
Yeah, so can we just set in CPU equal to 1 and still have an SMP kernel?
Well, that's a lot of what sort of happens today. I would actually want to go look at the diffs. I think the diffs over time have gotten smaller in the MI code even. I would have to go look.
There's a few things, like in the context switch code, maybe we have some little micro optimizations, like
maybe Sched 4BSD probably does.
Yeah, or
because
even
of how
ELE, like you don't need to go look at other CPU
so the run queue crap in Sched 4BSD is definitely simpler because it's either a global thing or you have the layer of your per CPU queue before the global thing.
Right.
Whereas ULE, it's always per CPU and it's different.
Yeah.
So, but I don't care enough about Sched 4BSD to like break those if defs. Quite honestly, I don't want to go.
Yeah,
mess
I'm
with it.
happy to just delete a bunch of AMD 64 code, but more generally, yeah, we almost certainly shouldn't be adding new if defs along those lines.
It might be worth seeing if there are some that can be trimmed that aren't atrocious. I think related was on AMD 64. I think it was in 14. We now mandate early AP startup. I think we made it so that if you build without that on AMD 64, it errors. Yeah, because that kept getting broken. It would be good if we got all the architectures on board with doing that, although I know it gets a little tricky because it's harder to get IPIs working early. Yeah, when you want NuBus to enumerate your interrupt controller sequence and IPIs, then that's when it gets messy, turns sideways. Okay, we should probably break. You can still hack on the HackMD page. I will probably sometime tomorrow. I will do a sync. I periodically push it to where I have it on GitHub so we can kind of have versions and see the log for what we did at each conference. But feel free to keep hacking on it. I think our break is about 30 minutes. Is that right? We come back at 3:30-ish, something. Don't forget, I'll put the survey link back up during the break. Don't forget to try to look at the survey if you get a chance. And we'll be back here at around 3:30 for our last talk of the day.
And one other question I have.
Oh, go for it.
One other question I have.
Oh, okay. Is that, can you hear me at all? Am I, thumbs up from there? Okay, cool. Looks like a bunch of people are filing in. That's fine.
Okay, folks, if we can find our way to our seats. We are nearly at the end of our summit for this year. And to close us out, we have a talk from Alex from Antithesis. So I'm going to turn it over to him. Talk to us about what you do.
Okay. Hello, everybody. So I'm here from a company called Antithesis, and I'm going to tell you about a very unusual thing that we've done with Beehive. Namely, the title of the talk, Building a Deterministic Hypervisor with Beehive. So first off, as about an introduction, what is Antithesis? Antithesis is we're a software testing company, and in particular, we are providing deterministic end-to-end software testing in the cloud, right? And why are we here at the FreeBSD Developer Conference? Well, our deterministic hypervisor is built on Beehive, and it, of course, therefore runs on FreeBSD. This is a project that started about 5 years ago, so I think FreeBSD 11 initially. And this is kind of the backbone of our entire environment. And I'm going to show you this rather complicated diagram just to understand the whole system that we're talking about, but we're going to really focus on just the deterministic hypervisor. So conceptually, the thing Antithesis does is we run entire simulated workloads that represent some kind of experiment. We want to run them in a deterministic environment for which we've created a deterministic hypervisor, which we call the determinator. That hypervisor, the determinator, is controlled by a piece of software that guides its exploration. Essentially, it's a fuzzer, right? So there's an external control system that decides what should be run in the hypervisor. And then we use that to try to find software bugs. And then we take those bugs, we collect them, we process them, and we generate reports that we show to our users. And lots of pieces of the system are in flux. We're still developing it. There's lots of capabilities that are growing up over time. But again, I just want to tell you about the Determinator, which is our deterministic hypervisor based on Beehive. Now, the format of this talk is going to be a little bit funny. We're going to play a game. Okay? So in these slides, you'll see a question. And then I'm going to give you a second to kind of think about it. You can shout the answer at me if you want. You probably shouldn't. I'm going to give you the answer, right? My answer, at least. For some of these, your answer might be different. But if you're happy with your answer, give yourself a point. Okay? Like, honor system, I trust you, I believe in you. But that's kind of what we're doing. And just before we start, the reason we're here is because, well, we built this on Beehive. It runs on FreeBSD. We're very grateful that we got to build on this platform. And we think it's very cool to just share with you, like, you know, kind of the joy of doing something unusual with open source. You know, something that's working on this, honestly, over the years has made me incredibly happy, and I kind of want to just tell you about it. So we're here to gush. Okay, so let's kind of set the scene here a little bit. So for starters, what's Beehive? That's the question, right? And I know everyone here probably knows, but Beehive is FreeBSD's Type 2 hypervisor. Right now, it supports Intel and AMD x86. There's a Beehive ARM project somewhere that I've followed a little bit, but it's not, I think, in the main source tree yet. It is now. Oh, excellent. Great news, perfect. Yeah, like I said, we started with FreeBSD 11, so some of my knowledge is very out of date. Fine, so that's Beehive. Enjoy your point if you got a point. Keep track of them. All right, so what's VMM? Again, you probably know. VMM is the kernel module part of Beehive. So Beehive is the whole thing, but Beehive is also a user-level application, and that interacts with a VM, but the kind of guts of the VM are provided by a kernel module, VMM. And finally, what's VMX? So VMX, which we're going to talk about a lot, that is Intel's x86 virtual machine extensions. So this is invented over the past, I don't know, 10 or 15 years. This is like the hardware support for making virtual machines a lot faster. And AMD has their own completely different ones. I'm only going to talk about Intel because right now our implementation only really uses the Intel ones. This is an area where like it's x86, but they're two like if you open up the Beehive source tree, there's just two different directories. There's like, here's all the Intel stuff, here's all the AMD stuff, and they do not really intersect very much. So we in our development, we said, okay, what does our cloud provider have? It's a ton of Intel boxes, so we focused on Intel as our starting point. So there's almost identical stuff in the AMD world, but it's all subtly different in ways that I have not had to learn how yet. So I'm very happy to just talk about the Intel environment here. So this is all stuff you hopefully know, but let's all get on the same page. Now, okay, let's talk about the other part of the talk. What is determinism? What is a deterministic algorithm? What are the attributes of a deterministic algorithm? Take a moment, think about it. There's three things I want to hit here, right? The first thing with a deterministic algorithm is, given a particular input, right, you want to always produce the same output. Determinism, yay. But with the same sequence of underlying machine states. And what do we mean by that? Well, okay, for starters, let's get the obvious thing out of the way. If I give you a different input and you produce the same output, that's not determinism, that's just the input being irrelevant. Right, but this final statement is very important, this underlying sequence of machine states. What that's saying is not just you get the same answer every time, but that the internals of the computer, to the extent that they matter, to the extent that they affect future answers, are the same as well. So it's not just you ran this one computation, you got the same result. It's that all the subsequent computations you're running as a follow-on to what you just did will always also have the same underlying state affecting them. And this is very important because if you get this part wrong, the other stuff doesn't work, right? So hopefully we're kind of, hopefully people got some points. Let's get more annoying, right? Well, okay, first off, why do we want determinism in software testing specifically? You can shout out a guess if you want. Reproducibility. Exactly. And there's our cute little mascot. His name is Snouty. So in particular, in software testing, it sure would be nice to, like, if you find something that looks like a bug, it sure would be nice to go back to it over and over again to analyze it. This has several advantages. One advantage is you can do destructive things with it. You can say, okay, I'm going to just I think my application crashed. I'm going to make it drop core and look at its stuff, and I'm going to decide, oh, I did that wrong, and then go back. And being able to try the same situation over and over again is high value. And also, honestly, how many times have you been in a situation where a test failed, and you go to someone who's responsible, and they're like, yeah, it's a flaky test, right? And how many times have you been in a situation where a test failed once, and you're coming back to it, it takes you months of rerunning it to be certain that you've actually fixed anything. So that's all some of the reasons we value reproducibility. This is why we're really chasing determinism as the thing that we want. Now, to kind of harken back to that initial picture, we're using the deterministic hypervisor for a very particular thing. We're starting with something that's a hypervisor for you to do anything you want with, right? You can run video editing software in Beehive that happens to be on a different platform, stuff like that. You can do all kinds of things. We have this hooked into a particular system for a particular task. And this is going to come up a lot in terms of the design decisions that we've made and the reasons that we're able to get determinism, which probably sounds a bit impossible if you just kind of say, how would I do that? Why hasn't anyone done that? So let's talk about determinism. Is sending a message over the network deterministic? Everyone's shaking their heads like, no, yeah. And you can think of all kinds of reasons why, including this will just fail sometimes. The underlying network stack might have to resend things, and there's latency involved, and you're interacting with the real world on so many levels. Like, this is just not going to be deterministic, right? Fine, we all get that. So RDTSC, if you don't know, that's just read the timestamp counter, right? That's like a really low-level way to just get the clock. So it's like reading the clock, and then reading the clock again, and then just returning the delta of like what you read. Is that deterministic? Again, everyone's shaking their head, which is good, because no, it's not. Like even if you didn't care about what the values were, even if you just wanted the deltas, you don't have that amazing amount of precision in the execution of instructions. All kinds of things happen to disrupt that flow. There's branch prediction, there's interrupts maybe, depending on where you are. Like, not deterministic, right? And finally, okay, let's go even simpler, right? Let's just say, what if I just, and sorry to switch languages on you, that's very mean of me, but what if I just wrote a literal to a memory address, right? That's all I'm doing. I'm just writing one to some memory location. Is that deterministic? Getting a lot of no's. Yeah, like, it depends on how you look at it, right? Like you can imagine a world where that's deterministic and you'd have to do a lot of work. So that's the first part that we're building towards is we're going to try to make that thing deterministic. And maybe that second thing you'll see. And we're just not going to do that first thing. OK, that's spoilers. We're not doing the first thing. At least not like that. You'll see what we actually do. So, OK. How do you contain non-deterministic behavior? Like, starting from the position that, fine, we just talked about how nothing in your computer does deterministic. It seems really bad, like you're in a lot of trouble. But if you ask your computer what's like 10 plus 10, it'll give you the right answer. Hopefully, or you should like hit the chip with a hammer and get a new one. Like at the very least, there's some basic things that the CPU does that really feel like they ought to be not deterministic on some level. If you can like adjust the boundaries of your abstraction so that the underlying state that you care about is deterministic, right? The game we're playing here with determinism is we say, OK, the machine state. What's the machine state? Is it the state of every electron in the CPU? No. We are finding a boundary where we can say everything below this line can be non-deterministic, and we don't care because it doesn't matter. Everything above this line has to be deterministic, and then we hope that nothing in that abstraction leaks, right? That's kind of the game we're playing. But we know that the CPU and the whole computer as a whole have a ton of non-deterministic behavior. So take a second and think about, OK, how do you contain it? How do you take all the stuff that the computer does that isn't deterministic, and how do you isolate it from what you're trying to do? Give it a sec. There's a couple of answers here. So 1, disable the behavior that you don't want, right? If it's a behavior that you don't need, just turn it off. Don't do it, right? 2, emulate it in some deterministic fashion, right? This is why we're using a hypervisor. You knew we were going to emulate a whole bunch of stuff. We were going to intercept what the physical hardware is trying to do, and we're going to try to contain the side effects through emulation. And finally, number 3, try to mitigate it. Try to detect it and hide the side effects in some way. Basically, this is a little bit different from emulation because emulation implies, I'm going to trap it. I'm going to not do the thing I was going to do. And when I say mitigate it, what I really mean is after the fact, I'm going to just take whatever bad stuff happened and I'm just going to make it go away. I'm going to hide it in some fashion. So that's the big picture approach to what we're doing, is we're trying to take this really non-deterministic system, if you look at the whole of it, we're trying to find the parts that are deterministic, and we're going to build out from there, and we're going to limit what the computer does to make sure that the thing we have left, which is still hopefully fit for purpose, is deterministic. And how do you know that you've actually fixed non-deterministic behavior? Like once you've done all these things, you spend months and months, possibly years, trying to force determinism on this system. How do you know that you've done it? Just test it. Test it a lot. Because there's no happy mathematical proof here. This is the world of real hardware. And in that world, you can look at the processor manual as your guide. You can look at the processor manual and you can say, golly gee, I think this will work if I do it, or that sounds really suspicious, I should turn it off. But the only way you know for sure is to test it constantly and relentlessly. And the whole time you're developing this thing, test it, right? Which is true of any software, but in particular, there's no backup here. So okay, so far generalities. Let's get a little bit into specifics. We talked previously, it sounds like time is a major problem for us. It sounds like even just running a single instruction, you don't really know how long that'll take. It's not like a really fixed, perfect, oh, this is exactly 5 nanoseconds kind of thing. So how do we make the passage of time deterministic in the context of a hypervisor? Remember, this is a hypervisor we're building. Well, we want to emulate the clock. And so, should have given you more time to think about that. I apologize. So the big idea here is, just like we do with a lot of stuff in VMs, we don't give the guest any access to real hardware. In our case, we made up this thing called vtime, which is just virtual time. And every possible time source, you try to read the timestamp counter, you try to read the HPET, all these things get its value just from this virtual time source. And this is what everyone does when trying to make a deterministic hypervisor. There are many approaches to this. I will tell you generally that we were able to do it using the PMC counters, which are the so on the Intel chip, there's all these debugging counters you can turn on, the performance monitoring counters. And we use those to basically count just the CPU execution cycles. And we were able to say for every n amount of work, we're going to advance the clock by a certain number of ticks. I'm purposefully being a little vague here. That's OK. So what do you do with that, really? OK, let me backtrack. So that allows you to solve the problem, well, begin to solve the problem of all these really basic things I'm doing. I'm just doing normal processing. I'm adding things together. I'm moving things around in memory. It allows you to try to solve the problem of the side effects of that need to be manageable. If I run a program for 1,000 instructions worth of stuff, I want the clock to always say the same value when I'm done. Now, another big source of non-determinism is concurrency, right? So you got all these CPUs, they're all doing stuff, and typically in a modern computer, they're kind of all just racing each other. Like you've worked with multi-threaded code. You've seen all the amount of stuff you had to do to like synchronize the data to not cause problems, not to beat race conditions. So how do you fix this on like the level of not just you want to get the right answer, but you want the whole machine state to be happy and correct and deterministic all the time? Well, you could emulate the whole CPU. You could spend like, I don't know, $50 million and convince someone to let you sign microcode and then write your own CPU microcode and then have that like slow the CPU down like tenfold in order to enforce ordering on everything. We didn't do any of that. We just disabled concurrency. So for the purposes of our system, the gift that we have is I can just run my workload on one CPU at a time, right? And if I can do that, if I can get away with that, it is so incredibly valuable to just do that and take a whole class of problems and throw them out, right? Yes? Go ahead.
You run on a single CPU or you run on multiple CPUs, but one CPU at a time?
So what I do, what we're doing is we're running the number of CPUs that you have is the number of VMs we're going to start up. Because the thing this is attached to is a fuzzer, right? And a fuzzer wants to explore a broad state space, right?
So each machine will only have one virtual CPU?
Each VM will have one CPU, yes. And so what that constraint allows us to do is to develop this in a couple of years as a small company instead of beating our heads against it and saying, can't be done, we don't have the resources, right? It's a trade-off, but it's almost worth it for the speed up it gives you if you're thinking about overall throughput, right? Like the thing about fuzzing, the thing about this problem space is it's not individual execution of one thread. I have to see thousands or millions of states. I have to explore, everything your program can do in a big tree of possible futures. And in that context, like removing all of the interlocks you would need to get multiple CPUs to play together nicely, multiple cores to play together nicely, makes you a lot faster in overall throughput and overall value for your hardware, right? Again, this is not a general purpose device. That's the key to like doing a lot of this stuff. And then finally, how do we make the entire physical world that's affecting our computer deterministic? Don't look at it, right? You don't want it. So do not talk to other physical machines. Minimize how much you talk to hardware, right? Like every piece of hardware your VM has to interact with is an entire device you have to impose determinism on, like from the ground up. And it's much better to cut away what you don't need and to say, do I need a real disk? No. Do I need a real network driver? No. Like you really want to limit, you want to create this big box. Like this whole project is creating a big box. And inside the box, determinism is happening. And then, okay, fine, but you want to talk to that box. Like the big box that's deterministic and nothing works, like you can't see inside it and you can't influence it, doesn't do anything. So now we get back to how do we deterministically ingest data from the outside world? I can't just create, a console port and be like, write to this console port whenever you want something to happen. I can just create a socket. This is where we can use something that, to my knowledge, Beehive typically doesn't really make use of, which is very convenient because we don't have to override it. So there's this thing in VMX called vmcall. I think on AMD this is called, I don't remember actually what it's called. But vmcall is an instruction that does nothing. Or rather, if you run it just on your computer that's not virtualized, it'll just tell you that that does nothing. If you run it inside a machine that's running in a guest OS, it'll just call out to the host. There's no defined action other than cause a VM exit. So exit from the guest to the host. And what this VM call instruction lets you do as a hypervisor designer is you can just have it do whatever, right? You have your own, just slap your own API on top of it and say, every time I make a VM call, like read register, I don't know, RAX or something. And if that says do this, then read register R8 and then use that as the value for this function you made up. So this lets you create a really efficient communication channel between the guest and the host if you're able to control the host and tell it, hey, this is what this API does. And you can really minimize side effects with this approach. You can say, you know, it's basically an instruction. You call it, something happens like while the guest is frozen, and then the host returns control back to you, and whatever magical thing you want to happen happens. In this case, we can use it very easily to have I/O without side effects, right? You only ingest data when you ask for it, and you only emit data when you request it, and otherwise it's a nice black box. It's very tidy. This is the answer to the question of, well, the world outside is non-deterministic, the world inside is deterministic, but in order to run this as a program that does anything, I have to control it from outside, and I have to see the results of what I do. So the next thing is kind of, fine, I've got this interface. The way that VM call works, like you make the VM call and you can, in our case, like you can read data in, you can get data out. What if you wanted to kind of more of a push interface? Like just armed with this one instruction that just says, when I make this instruction, the outside world is going to give me, let's say, a byte of data, or it's going to give me a line of command to run in bash or something. What if I wanted to make it so the outside could like control the timing of these things? Give it a sec. I know this is getting a little harder to like follow, or to at least to guess. Well, just inject an interrupt, right? Right, do the VM call in the handler, inject an interrupt from outside, and say, I'm gonna run to a certain point in time. I'm gonna schedule an interrupt at that point, and then I'm gonna just do a read. I'm gonna read data in, and so now I've got this system where I've got an outside controller on this deterministic inside. And then, okay, fine, but I just told you there's no disks, there's no network, there's no like hardware, right? And I'm telling you, oh, it's a test platform, right? Ooh, we're doing deterministic simulation testing with a box that does nothing, that has way more limitations than your computer. How do we do that? Give it a sec. How would you do it? How would you test a whole big system in this framework that's just running on a single core? Well, you simulate a lot of stuff, right? And in particular, you know, if you have a bunch of services, if you have a bunch of servers, if you have a bunch of nodes, put them all in containers, network them via virtual bridge. That is something that not at a lot of fine-grained levels, but at the level that, at a lot of levels that you do care about, though, that is something that behaves like a big system in a simulation. And if you just did this like on your home computer with, you know, some big like database engine or something, it would probably not work because it'd be like, all my connections timed out. I don't have any resources. I can't do anything. This is the convenience of lying to it about the time. This is the convenience of simulating all these things. And then once you start simulating these things, like I'm making use of the guest OS to help me, right? Like from the get-go, from the VM call, like the guest OS is also something I'm providing. It's tailored to my needs as the person running the experiment. And I can have the guest OS, you know, I don't just have a network bridge, I have a faulty network bridge, right? So this is where the testing comes in. I'm gonna have the network bridge just like mess up your packets. And I'm gonna, every every 3 seconds, I'm going to force a leader election on you if you're some kind of distributed database, for example. Like I can go wild with how, like by getting the guest OS to play along, I can get these simulated things to have a really bad time very quickly, right? And this is kind of what the determinator is for. It's providing the big box in which this whole experiment runs. And in that box, we are causing lots of badness to happen very aggressively. And then we're collecting lots of data about what we do. And we're using the determinism properties to explore that state space of all the possible futures of bad stuff happening and causing you to have a leader election that causes the database to delete itself. As an example, it's not the only thing we test, but a lot of our early adopters were people who had these kind of, I sure want to know if my database can have $1 million bug situation. So that's kind of what we're doing is this is a very unusual way to use a hypervisor, which is we're playing together with these other ways of simulating a whole environment. What's next? OK, so to kind of get back to how you actually build something deterministic, is the TLB, is the translation look-aside buffer deterministic? No. So not really. That should just say no. I was being way too forgiving of the TLB there. So what I mean by this is, like, you've got your page tables, and the TLB is like caches the result of that lookup, and it just drops stuff at random. There's also like the whole procedure. There's TLB invalidation. There's TLB shoot down. But you're never guaranteed something's in the TLB, right? And this is a great example of like why controlling time is so important. Because you do something that's just anything that requires the memory access. How long does that take? Well, it really depends on whether the result's already cached in the TLB. If it's not, you're doing a multi-level page table walk. You're popping that into the TLB. There's all this stuff happening. If you do just have it all cached, you skip all that stuff, right? So this is an example of one thing that's kind of your enemy here. If you care about like real-world clocks at all, this will completely kill you. Fortunately, we don't, right? Fortunately, we don't. But regardless, in our world, is the TLB deterministic? Well, now it gets ugly, right? If you read your x86 programmer's manual, there's a great section on the rules for TLB shootdown, right? Or not just shootdown, but invalidation. Forget shootdown, we're not doing multiple cores. Shootdown's the bad one. Invalidation's easy. There's all the rules for invalidation. And you'll notice that some of the rules are, you have to do this or your operating system won't work, right? And then there's that section of like optional stuff, right? And one of the optional things is if I've increased my privilege, right? Let's say something wasn't executable and now it is, right? I've marked a page executable. Do I need to invalidate the TLB? Now, in the opposite case, if I've marked something non-executable that used to be executable, if I don't invalidate the TLB right away, that's a security hole, like gigantic security hole, and everyone will yell at you and get mad. In the other case, most operating systems say, golly gee, I can save myself a TLB invalidation if I just, cause a spurious fault every now and again, because you've escalated privilege. Like you've gone from non-executable to executable. And if you don't flush the TLB, all that happens is now there's some possibility before it gets cleared out by some other thing anyway, that you'll attempt to do something that you by all rights can do, and you'll get a fault that says you can't do that. But then the operating system will say, oh, that's a fake fault. That doesn't matter. I was just lazy before. And you'll just rerun that operation, and nothing bad will happen, right? Sounds great. Sounds great. Yay. That's like, in the real world, that's great. That's perfect. in our world, your guest OS now non-deterministically goes into a handler based on what I'm going to call non-architectural state, the state that you don't know what that state is, that you have no way of like really controlling. And I said before, my clock runs off of what instructions I'm running, right? Well, now there's a little loop that goes through where it just did a couple of extra instructions. So this is the kind of stuff you're fighting, is oftentimes everywhere that you can do something slightly non-deterministic, but it makes the whole computer faster, almost every modern OS has done that thing, right? And so how do you deal with that? How do you get the guest OS to play nice? When by default, anything you're using, and we're mostly using Linux in the guest, to be clear, because that's what you run everybody's containers on. How do you get the guest OS to play nice? And I'm going to actually give you some time to think about this. So first thing you can do is lie to it. Like, you've got this great facility for the CPU ID, which is every operating system is querying the hardware for like, hey, what can you do? And every hypervisor already lies its butt off here. There's a lot of features that your underlying hardware supports that the hypervisor says, no, don't do that, don't try. So that's the first part. Then you can try to interpose and mitigate. You can say, okay, well, fine, you're going to cause a spurious fault. I'm going to trap all the faults. I'm going to decide whether they're spurious, and I'm going to hide it from you, right? This is the mitigation task, right? I'm going to say, no, you can't see that happened, right? This is annoying. This is a pain in the butt because now you're fighting the guest. You're going to do this a lot. When you write this thing, you're going to do this a lot for all kinds of stuff. But there's another answer too, which is you modify the guest, right? You go in the kernel and you say, no, I want you to do the nice thing, not the fast thing. This will save you a lot of time. Like part of like doing this, part of accomplishing something quickly here is limit your contact surface. Like, don't jump off the deepest end you can find and say, oh yeah, I bet I can force any OS to be deterministic. Make the OS play nice, right? Trick it, or tell it not to do things, or just change it. Just change it. The beauty of open source, the beauty of all open source, Linux, FreeBSD, all that stuff together, is we can change what we do. So we have a lot of control over the interface that if I was trying to run like Windows in the guest, I would not have. So that's a lot of the big picture. I want to kind of take a quick break, just to pause for a sec. I think there's maybe, if anyone has like foundational questions, I kind of want to get them out of the way. I just want to make sure you're at least somewhat happy that you know where the heck I'm going with this, that I'm not just saying a lot of BS. Are we good? Okay, we're good. Okay, so as a quick summary, what have we done? Or what have I described? You haven't seen me do it. I didn't sit at the computer and do all these things. So the Determinator starts out with Beehive, we heavily modify it, and we disable a lot of features that we don't need. Not because those features are bad, but because we strategically just identified things that we couldn't do, or couldn't do in a reasonable amount of time. Every deterministic hypervisor has to start out with an emulated time source. That's just kind of pretty much non-negotiable. In our case, we also run everything on a single core. So we get rid of a whole host of problems by just getting rid of concurrency. And finally, we simplify your I/O down to this one custom-designed deterministic I/O channel. It's very simple. It's basically designed to be side effect free from the view of the guest. And that also removes a whole host of problems, because now the contact surface between the deterministic box that contains your experiment and the outside world that contains everything else is as small as we can make it while still being able to control it and being able to see inside. And then finally, in our weird case, the guest image represents an entire experiment. So we run all these containers in there, we hook them together, we have fake devices for them inside the guest. This is what we're doing. And then in terms of practically building this, just some quick notes. Like, the thing that we really learned very quickly was you want really detailed logging as you do this design. Because the thing you're starting with is non-deterministic. The thing you're starting with just does not do the thing that you want the end product to do. But you're starting with a mature piece of software with a lot of components, like you're modifying something that already exists. And so what I very quickly found was I just wanted to log a ton of information every time I was in the host. I wanted to, the easiest way to do this is just hash all your registers, hash your memory, hash everything, and then keep track of that as often as you can, and then run in parallel. And the first time you see a divergence, that's the thing you have to investigate. You have to go back and say, what did this? What was the instruction that caused this divergence? The nice thing about that is like you can read the RIP to get the instruction pointer. You can go in your guest, you can look at the kernel symbols, you can fire up your kernel browser, and you can say, aha, it's in this function. You know? And if it's the like, oh, the TLB flush function is causing me problems, well, I better learn about what the TLB flush function actually does, right? So the first thing I did actually when building this is not because it's bad, but because it wasn't suitable for the thing I was doing. I wrote my own logging engine. I didn't use the like built-in syslog-d-ish type kernel stuff. That's designed for like real people with real systems. I just wanted to capture like a terabyte of data in an hour. And I didn't want to lose a single line. I didn't want like a ring buffer that's like, oh, well, you tried to log a lot of information and I lost a line. You know, I didn't want that. And then the other thing I did with my logs is I tagged them all. I had a counter, and every time something deterministic happens, it gets tagged with that counter. And every time something non-deterministic happens, it doesn't get tagged with the counter. And then I can take like 10 or 20 of these things, and I can zip them together, and I can just say, okay, what was the first deterministic thing? Ah, okay, they all match. Or like number 10 didn't match, and now it's a 1 in 10 aberration, right? So without this, it just wouldn't have worked. Like this was the first thing, is like logging. The second thing is very quickly, I built the first version of this like in a box under my desk, but eventually we were running these things in the cloud. And so I found it very valuable to like write my own kernel panic handler. Because when you panic the kernel, and you do panic the kernel when you write these things because you do things when you shouldn't, because you're manipulating big chunks of memory, you're doing all kinds of things in the kernel, and you're doing them very nastily. When you panic your box, you know, it drops a little core file, you can go and open it. But in the cloud, unless you take pains to like preserve that, the thing that happens is the cloud provider will just destroy that whole thing. Like your box died, it'll kill that stuff, and unless you want to like attach a disk every time and have all kinds of special setup, I found it more valuable to just say, you know what, I know this panic is probably not going to destroy like my ability to SSH into the box. I think it's just going to destroy my experiment. And just being able to SSH into the box and look at it when it's running was incredibly valuable. So this is like another, like I'm not going to call myself the world's greatest kernel hacker or anything. I obviously am not. But making your iteration loop faster was really valuable to me in that way. And then finally, to go back to the testing thing, what we really found is that like we wanted to build in correctness checks as we were running at kind of the macro level, at the micro level. Every time we're redoing something that we already have a piece of data that's like, here's how it should turn out, we should look at that piece of data and say, okay, I reran this, like I'm using the determinism for replayability, but when I replay, I should check the result. I should make sure that I did get a deterministic result. And this way, every test we run is also retesting this component in a way that's more purposeful than just saying, oh, the test failed for a mysterious reason. I have to spend a week figuring out why. And the answer is because every piece of architecture on top of this thing was expecting it to be deterministic, and it wasn't. Like being able to identify these correctness problems immediately was really high value when we built this. So fine, we have the determinator. And like any good determinator, it should travel through time, right? That's the important quality of terminators and determinators. So let's make this thing a time travel debugger. What do I mean by that? Well, okay, so we've got deterministic replay. Yay, hooray. But deterministic replay takes a while. It's replay. Ugh. I don't want to replay states. How do I speed up replay? Snapshots. Yes. Bold snapshots. Correct. Snapshots. Take some snapshots. And in our case, we want really efficient, fast snapshots of this very limited system that we've built. So what data needs to be in the snapshot? Now, this whole thing, for reference, the only device it's connected to that's anything like a real device is the AHCI CD emulation. And so you're basically just importing your guest OS as a live CD, because that's an environment where almost every OS has a live CD. And the nice thing about live CD is it's already just assuming that the CD itself is just ROM, right? That it can't change anything, in that giant wad of data. So that giant wad of data, you don't have to worry about preserving its state other than like that little device. So given that we don't have any devices, what data needs to be in the snapshot? Like, what is a full snapshot of this system? Just kind of.
VMCF.
Hmm?
The whole VMCF.
Yeah, sort of. Yeah, so yeah, the whole VMCS, all the guest registers, all the emulated device state for your fake little set of devices, and then all the guest memory. So that's a lot of stuff, but it's much less than how do you actually make a snapshot of normal Beehive? And we built this before the latest round of Beehive snapshotting stuff was available. This is very different. This is, I believe, much faster unless techno wizardry beyond my ken has happened in Beehive. It's much simpler, right? Now, of these three things, guest memory, your registers, and your emulated device state, which I just told you is tiny, so feel free to ignore that. Which of these is the biggest? Memory, right? Given our read-only devices. So really, snapshotting is mostly about efficiently snapshotting memory. Now, to backtrack a little bit, how does your computer map a linear address to a physical address? Linear address in program space to a physical address in RAM, right? Page tables. Everybody loves page tables. Now, how does VMX, how does the hardware with all the virtualization support map a guest physical address, so what your guest OS thinks the physical address is, to a host physical address, i.e. the real address in your real memory? Extended page tables, EPT, right? More page tables. So we've taken page tables and we've added another layer of page tables to it, which does not make lookups twice as slow. It makes them like an order of magnitude slower, because every page table, a linear address to a physical address, you go through 4 or 5 levels, usually 4 levels. We haven't gotten to 5 yet, but it's out there. You go through 4 levels of indexing, right? And each of those points to the physical address of the next page table down. Well, to map a physical address to a host physical address, you've got to go through page tables. So every single normal page table step is a whole page table walk of this EPT thing. This is still way faster than what we used to do back in the dark ages before hardware did this, where you just kind of did this all in software and kind of faked it out. And I can't even describe it, but you basically just made your own fake page table and then you replaced it with the real one, and it doesn't matter. We're not doing that anymore. We're doing this. So extended page tables. The nice feature of extended page tables is what happens when an EPT entry, so a line in EPT, says you can't do that. When it says, oh, this is not accessible to you. You can't keep walking this page table. So in a normal page table, you get a page table fault, right? In an EPT, you get the EPT fault. And the difference is an EPT fault goes to your hypervisor, does not go to the guest. So this is telling the hypervisor, oh, you probably should want to fill this out. Just like in the normal case with your computer, the operating system running some stuff at user land, the operating system could go, oh yeah, I can just fill that out. It's fine. It's not a real fault. So we can use this. We can abuse this, right? So let's just go ahead and say I've implemented copy and write memory with EPT. Can we do that? How do we do it? How do we use the thing I just said to do copy on write memory?
Mark them like read only.
Yeah. You mark them read only. You just take away the write permissions on everything. And then every time someone tries to write something, you get an EPT fault saying, ha, the guest OS thinks it's about to write to this location. And then you just clone the page, you make a writable page. And now, the nice thing about this is usually these writes have pretty good locality of reference. Like once you start writing to a page, you're probably going to write to a lot of that page. Because all your program data kind of lives in a tight little area usually. Or if you're just like streaming out data like a log or something, or just building up a file, it's usually, you start from the beginning, you go to the end. It's pages at a time. So the nice thing about this approach is, yeah, you get a lot of VM exits. So VM exits cost time, so you want to minimize them. Here, you'll get a VM exit the first time you want to copy and write something. You make it writable, and then you just aggregate further writes. And so now, armed with that, I can say my starting point is all my memory is read-only. And then I want to do this copy on write mechanism to capture everything that happens. And at some point, I'm going to want to take a snapshot. I'm going to want to take all the stuff that's happened since my last snapshot, and I'm going to store it. So when I take that second snapshot, how much of guest memory actually do I need to store? Give it a sec. Think it through. Just the stuff that changed, right? So I have a list of everything that's writable. I take all those writable things, I make them a next layer of read-only memory, and I just have a state tree that says I took a snapshot of everything, and then I took a snapshot of, let's say, 10 or 100 pages that changed, and I took another snapshot, and each one, as long as you're allowed to just reference your parents, each one can be very, very small, comparatively. And what you're really taking advantage of here is, programs like to keep their data in like a pretty orderly shape, sort of. Maybe I'm being a little optimistic, but so these things can actually be really small. And they can also be really fast. Because how do you load a snapshot? Like, if all I'm storing for each snapshot is just some changes, I don't need to rewrite the contents of memory. I just have to save all the non-memory state, just save a bunch of registers. Oh no, it's a couple of kilobytes, let's say. There's a lot of registers on a CISC machine that you don't think about. But just save some registers. And then for all the memory, all I'm doing is remapping. I'm remapping an EPT. I'm not copying around whole pages of data. I'm just changing one entry to another. So I'm just keeping a narrow, small set of diffs. And that is actually amazingly fast in the context of our system. Like, it makes it very easy to go down a certain path and say, what happens if I do this, if I do this, if I do this? And then backtrack and say, OK, now I want to see this other result instead. And this is a very impressive result. You can do a lot with it. Interestingly enough, once you've done that, once you have this mechanism, how much state can the VM share? Remember, Beehive, the way Beehive is implemented, every VM has its own Beehive application, user level. But it's all talking to one kernel module VMM, right? There's different threads. Each VM has its own thread because it's the user process. But it's all in the kernel. All that data is shared. How can the VM share snapshot? Can I have VM number 1 save a snapshot and VM number 2 load that snapshot? Yes. It's just a bunch of read-only data once you save it, right? And all those pages at the kernel level, they're all shared. You don't care. It's actually really nice. Now, I'm going to get to that in a second. But the really nice thing about this with our model of, OK, I'm doing a big parallel experiment, is if I told you I'm going to take I'm going to take an experiment that represents multiple machines, right? I'm going to put them all together in simulation. I'm going to run it on one VM, right? Well, multiple machines usually take up a lot of RAM, right? You know, most people's big cluster-ish database applications, they're probably not going to run in like a gig of RAM, right? And I'm telling you, I'm going to start 1 VM per core. OK, where do you get the RAM? Where do you get 20 gigs per core? No machine has that. That's a weird machine. But I really want to make use of all the cores. Now, though, they're sharing all that memory, right? If they all start from the same state, like let's say the size of my let's say the working size of my image is 20 gigs. They all start from the same state. I need to just get one machine through startup, make that 20 gig snapshot, and then the rest of them load it read only. And so I'm actually, not only am I being faster, I'm actually able to use all my resources on this machine. I'm actually able to share so much of memory very, very flexibly because I wanted the snapshotting capability, because I didn't want to bother to replay everything from the start, right? This is an amazing leg up for actually getting decent throughput out of this machine that I'm torturing very weirdly with these VMs. So now, can the different snapshots share their changed pages? This gets a little ickier. This is like, you could probably come up with a way to do this, right? And so they can, but you have to be willing to reference count and deduplicate, and you have to be willing to trade some time complexity to say, OK, have I actually seen this page already? Or is this really a duplicate of something else I've already done? I'm not going to go into too much detail about whether it's worth it or not. This is actually, we're kind of in between how we do this, because we decided that there's trade-offs that we kind of have different ideas about whether the trade-offs are worth it or not. But you can, in fact, you can trade a bit of computation time to like try to deduplicate these things and get even more efficiency. You can really squish these things down and try to make the most use of your memory, or you can be a little bit more laissez-faire about it and just run very fast. And then, OK, you have all these snapshots. You're probably making a lot of them. Can you delete them? Can you forget them? As you're running, as the whole system is going, all these snapshots only exist, like, forget about like cold storage, like pretend these are all just hot snapshots. All that matters is like during your big, multi-hour exploration of a program, can you delete these things? So the answer is yes, but you might need to do some housekeeping. You might have to be like, well, my children care about these states. I have to like pass it on, and I can't just delete some pages. It really depends on implementation details. They're kind of a little, don't really matter. But at the very simplest, like if you just have a leaf somewhere, if you have a state that like, you spend 10 minutes getting to a state and you made a snapshot of it, and then you spent 10 minutes exploring what follow-up futures can happen from that situation. You got a lot of value out of the snapshot being there, so you didn't have to spend 10 minutes each time replaying it. And then you said, OK, I'm done with this one. I don't care about this. I don't care about any children of this possible future. Just clean them all up. It's really easy. It's really tidy. So this is pretty powerful without a lot of effort. This was very quick to implement. I was shocked how fast this fell out of the other stuff. And I was also shocked how much more efficient this made the whole machine. And that is time travel debugging on top of this determinator thing. So, OK. Kind of adding it all up. What do we have? What did we make? What did we do with Beehive? Well, we made a deterministic hypervisor, the determinator, that deterministically reproduces a certain workload state. We support many VMs exploring in parallel, partially because we made design decisions that forced us to do this if we wanted to be efficient at all, which was very smart on our parts, but also very lazy. That's the best combination you can be. And also, like, it's a pretty handy time travel debugger. Like, once you have determinism, it's a lot easier to, snapshot things and reproduce them. You get a lot more value out of it, because now instead of just run this snapshot and then immediately diverge and it doesn't really matter, Now it's run this snapshot, and every time I want to see the thing I already saw, it takes me 10x or 100x less time. And so that's the big kind of thing. That's the big picture of this component. And then in terms of like where this is going, what we're doing with it, there's always room for more optimization. You know, I've described something that's a kind of, it's not a prototype. This exists. You can pay to use this. Please pay us to play in our sandbox. It's great. It's amazingly powerful. We have plenty of testimonials about how great this is, and it really does feel really cool to use too. But there's room to optimize the back end. Like there's always room to optimize the back end, and especially as your trade-offs change over time, you might go back and even just say, oh, I optimized this once for one use case. I'm going to optimize it for a different use case now. You can certainly get more flexible with the I/O channels, with the output capture. And a thing that would be very nice in our case is also to kind of make the guest image, the system under test, a little bit more hot swappable. Like I'd really love to just say, I did all this setup stuff, and then at the end, I'm going to like hammer in like a small patch. Or even I got to a fail state, and what if I change one line of code? Could I maybe hammer in like a, 2-line patch in a state I'm already in? Like this is still experimental. We're still working on this, but this would really be the next valuable thing to do. And finally, like because this is running on like the Amazon cloud mostly right now, when Beehive has ARM64, which apparently is actually now, I would eventually like to do this for ARM64. The caveat there is all of the stuff I just described, I have to start again from scratch. Because this is all the behavior of the architecture. And yeah, it's kind of in the processor manual, but is the processor manual telling you 100% the truth? It's not lying to you. It's just like, this is reading between the lines and guessing. And it's saying, well, I bet the implementation of this has to kind of give me this guarantee that no one ever spelled out because they don't want to promise you that. That's insane. Like, so eventually I would really love to play with the ARM side of this. And I'd be happy to do the AMD stuff if there's any reason, but it's basically the same machine when you're done. But that's actually a big lift. Like, I think it would be easier to do the like, let's do surgery in guest memory on the spot to change the program that you're running than it would be to like support a new architecture. But that's the kind of big place where we're going with this. That's kind of it. Like, there's going to be a lot of questions. Also, hopefully you kept score. I should have, or just vibesy. It's fine. There are some prizes. You don't have to tell me your score to get a prize. Just come up and get a prize later when we're done with this meeting, okay? like I don't want to be like, now let's fight. Let's see who's the best. But I do want to, before I open it up to questions, I just want to say we have a nice website. We are interested in people who want to work for us. We're interested in people who want to pay us to test their software. We're also in a context that matters a lot for open source software. We do have a program for the like tiny neglected open source things where the one maintainer is like making all the world's clocks function. We do have a program to nominate those, and we'll try to test them for free if we can figure out a way to test them. So very much like right now, this is a bespoke, complicated system. It's, this is, there'll be more individual level stuff available later. Right now, this is targeted kind of, it's not just targeted at big companies, but it's targeted at companies with resources to pay for all this compute. But we do have a program also for open source stuff, like load-bearing open source especially, that we'll try to take a look at it and say, is there a way we could test this and maybe give you some bugs and say, hey, there's a security flaw or there's a stability flaw that could affect like all of industrial society, and hopefully you'll have some questions because I just told you a bunch of weird stuff and said, yeah, you can do it. You can just do the impossible thing. It's fine. You'll be happy.
So you mentioned for testing the smaller open source projects and so on, if you could find a way to test it, what kind of things are practical to test with this versus which are maybe much more difficult at the moment?
So we're actually pretty good at finding ways to test a lot of stuff. There's the thing that's not super practical to test with this right now is if you were like, hey, I want to test a, kernel bug, right? Because I'm using the guest OS to do fault injection. I'm using the guest OS to kind of manage things a little bit. So we really started with concurrency testing primarily because, sorry, this is more going to business models than the hypervisor, but we started with concurrency testing because that's where people were like, I really care about finding very deep down, like bespoke, weird bugs in strange interactions of all these systems. We've tested games successfully. We've tested, crypto's another area where this is just concurrency testing again. That's not really a surprise that like the crypto people care. We do other kinds of fault injection. Honestly, the other thing that we found is a lot of modern software that you're used to just running on modern hardware. The timing environment that this is in is not like a perfect replica of a real computer. It does surprising things. It interleaves things in surprising ways. So a lot of software that's like, well, we think it's resilient, but we're not sure. Just loosening the guarantees that you get from running on a real machine and being like, well, this thing that happens 1 in a trillion times now happens 1 in 1,000 times. It's like interleaving or something. Like you find a lot of bugs really fast sometimes because you're able to just kind of change the like very fabric of like how time flows. You're able to like, I don't have a hard like, no, I can't do this for you because we find a lot of ways to test a lot of things. Like it's
Maybe
partly
as an
what we
example,
do.
Would it be practical to test something like ZFS, considering where we can compile and run the test in user space where it's not in the kernel?
I think it would be a bit of a lift, but I'm not going to say no.
Okay.
So that's a like I haven't thought about it.
Okay.
I don't know enough about the contact surface with ZFS exactly, but I would certainly be excited to try.
So can you give sort of an example of something where you found a bug that, I'm just trying to sort of categorize the kinds of things that you're finding that people had been, trying to find and then you were able to find when they hadn't.
I'm trying to think. Unfortunately, I don't have the customer case studies memorized. There's a bunch on the website, and I don't want it to be like, oh yeah, company XYZ had, this problem that we fixed, right? It's kind of,
I mean, the sort of things where you have sort of bad traffic coming in, or is it race conditions?
There's a lot of race conditions. So classic example is, you have your distributed database and you have strange interleavings of network traffic that cause, anytime you like have a partition especially, and suddenly you get into leader elections, you get into duplication, you get into all that weirdness, like being able to really perturb that over and over again. And in particular, this is where the like rest of the platform comes in. I don't mean to make this a sales pitch, but to understand why this is valuable, I kind of have to talk about it, right? So if I find something that looks like a bug, and then the fuzzer backtracks and it says, 1 second before that, there's this kind of weird little log message I've never seen before, right? So do that. Use the time travel, go back, and then try different things and see, like, once I've seen that log message, am I like doomed to failure? Or like, when's my like 50% to failure, right? Like, I found one failure here. Is that a whole class of bugs? Is that a whole class of failures? And you can kind of do, one of the values of this isn't just, honestly, one of the things I tell people is also like, run this and it'll turn up some bugs that you're like, I'm afraid to fix this. I'm not sure this exists in the real world. I'm afraid to fix it, like in terms of time commitment. But even then, you can just keep it in your back pocket. And then a month from now, if you're like, oh, I got that weird use case, like that's real, that bug is real, you can go back and say, oh, Antithesis found something like this. Let me play with that one. Give me back that one, unfreeze it. There's also like a property-based testing component to this. I didn't really talk about this. It happens at a different level. So nowadays, if you instrument your code with almost like assertions, but you can also have like a sometimes assertion or I visited this path or I've never visited this path assertion. And then we can say, oh, we triggered like this, we got it down this path. We got it down this fork that you can see. I don't think I answered your question. I'm sorry. What kinds of stuff can you find? So very weird interleaved control bugs in distributed databases or other distributed systems are actually remarkably easy to find if they exist. And that's high value to find them, like everyone, and they probably exist in your system. Like no one writes a perfect database from scratch. We've done normal style race conditions. We had a video game actually where we found just a normal like strange couple of behaviors happening at the same time. I'm not sure if it was threading related or something else, but we've done that kind of thing. And because inside the box, there's also just a bunch of fault injection that just goes like nuclear on your stuff. Like a lot of things that are very normal classes of bugs where it's just like, my system has a certain amount of resilience to like disk faults or to network faults or whatever. Just upping that fault rate catastrophically without destabilizing like the test harness itself is like high value because you can say under this amount of pressure, like things start to break down. And sometimes you'll look at that and you'll say, okay, I can live with that. And sometimes you'll look at that and say, oh, I didn't expect that to happen. I was hoping my system was more resilient than what I saw. So it finds a lot of things. It's very functional, but you need all the other layers working together to like guide the exploration.
Yeah, well, I mean, having worked on device drivers where, something happens and it goes crazy and then you don't know how to reproduce it.
Yeah.
So being able to reproduce it lets you get confidence that you actually found
Yeah, that's the highest value. And there is like the thing to be aware of is like I did say, the same inputs, same outputs, underlying state, right? Once you're in the realm of did I fix it and you're like, okay, I went through a whole version change and I'm running the different software, now you have to hunt for it again, right? That's a different input, right? You have to do some hunting again, but it does give you some good degree of confidence. And we do have pretty good reproducibility with aggressive searching over time. Like we don't have perfect confidence that if you ship me the next version of your software, I just will find the exact same bugs if they're still there. But we have fairly high confidence just from doing it a lot. Sorry, that's too much of a sales pitch. I should be more humble.
No, you answered the question. Thank you.
Okay. We got one here. All right.
So one of the changes to the guest test you do, I'm sure, is tweaking the random generator to be predictable, right?
Yes.
So as I understand, the product works by you have, let's say, a bunch of knobs to tweak timing, to tweak like seed for the random generator and stuff like that, and you run all of those, and see which set of knobs actually triggers some bug, right? And then you can go from there.
Yes.
And reproduce.
Yeah. So you're right. So that thing I talked about with the VM call, right? Attaching that to random, to dev random, do random, all those things, right? So that then every time I send a value down, it's like reseeding your RNG or it's adding to it. That's a way of controlling stuff. We actually have this whole like because you can just push in arbitrary commands, we have this kind of mini language that we're permuting where we in that little mini language we say, now do this kind of thing. Now I want to see this kind of fault. And if this kind of fault causes this behavior, I might permute it and say, okay, now do the same kind of fault but make it shorter or make it more expansive, or so there's different. The knobs are getting much more advanced. The starting point is exactly that. It's like change urandom. It's like just randomly like hit things with a hammer and see what happens. And then the exploration part is now we want to manipulate that history and try to, like, for example, if I have a history of like if my faults are like scripted, right? I can take this long sequence of events and I can try to trim it down, right? That's a popular thing to do, is try to minimize the reproduction of something. So there's a lot of flexibility if you build the guest to have these controls, to be able to tell it what to do, to be able to script it, to be able to command it in various ways. And there's a whole bunch of harnesses. I don't want to talk it up too much. Like it's, nothing that you probably haven't seen before, but in this environment, it becomes a lot more powerful to just have a fault injection harness of any kind because of the reproducibility. We're doing the running thing again, aren't we? Yes, yes, brilliant, perfect. Thank you so much for doing this for me.
Oh, that's no problem. I'll just keep asking questions at opposite corners of the room.
Yeah, that's the best way to do it. That's the best way to do it. No.
About time travel, I wasn't clear if you can like proportionally speed up VM execution and just like hit the gas and go faster than real time.
So most of the time you're going to be going slower than real time because you're doing things on one core, and the benefit is really the overall throughput of the system. To be clear, you're still testing like multi-core workloads. You're just using the OS scheduler to kind of simulate that. Anytime the system does just try to sleep, for example, you can skip large chunks of time though, right? If you tell me I'm going to sleep, I'm gonna wake me up, I can see all the interrupts that are queued. I know nothing's external is gonna happen unless I've decided that it happens. And so if you just tell me, yeah, all my threads are done, sleep for like, I don't know, 10 milliseconds, I'll just tell you 10 milliseconds are up, congratulations. And there are some workloads that run faster than real time because of that.
Are there any components that are suitable for upstreaming?
At this time, not so much because of how much of this was taking things away. And there's also the dimension of this is the foundation of a much larger system. Our hope was always that eventually this type of thing is going to be commodity, relatively. Like, as long as we're kind of the only people in the market doing this, we don't want to just be like, here, big company X, have all this work for free. That's kind of the joy of the BSD license, right? Is like we were able to develop this with the confidence that like it could pay for itself, but then we're not stuck being the like sole owners of it forever. Because like the thing that I have now, you wouldn't want it in the shape that it's in. Not because it's like ugly and prototypey and stuff, but because you'd have to figure out how to merge it back with a completely different system that is designed to just kind of replace, right? That's kind of the answer to the upstream question. But we're not banking on this being like our super secret proprietary tech forever. We're just happy to like have done this. We're very impressed that we were able to do this because some of it's, we wouldn't have done this if we thought it was completely impossible. But we are very happy that it worked the way that it did. Like there's some pleasant surprises when you go down this road. Hopefully I've communicated that. And also, honestly, it's kind of fun to discover just what you can do with commodity software that we're all familiar with, that many, many people have put many years of work into, and that's why you're able to build on top of it. That's why nobody wants to build a hypervisor from scratch. Oh, okay, lots of people do, Nobody who has a company that needs to like succeed or fail, you know, with money wants to build a hypervisor from scratch if they can avoid it. Like that's academics and hobbyists, and I love them to death. But we're so happy to have this platform to build on top of. And the upstream question is hopefully answered by that a little bit.
Are there things that were missing in FreeBSD that would have helped you? Things like platform support of some kind, or
Good question. I think for the thing that we're doing, it's got our bases pretty covered. Like there are a couple of limitations that have more to do with stuff that we've done. You know, our own upgrade cycle internally and some other stuff like that. But I've found, like, for making a weird hypervisor that runs in the cloud, this has been a really good experience. And the Beehive architecture is very friendly for that. It's very easy to kind of compartmentalize it. I found it very easy to, you know, add syscalls and have it do weird stuff and like completely change the like underside of it. And as someone before this project, I'd done kernel development before, but never on FreeBSD. And just, I know this will sound like baby stuff maybe to some people, but like even just like the RB tree is nice. And some of the like spin locks and stuff, and a lot of stuff made me happy. My one place where I was tearing out my hair briefly was that when you're in this particular space, you know, you've got your kind of object-oriented-ish C, so you put like VM underscore blah, blah, blah to do VM stuff, right? And then you need to do some weird thing with pages, and suddenly VM is the virtual memory subsystem, and you're like, oh no, it's the same. Like, maybe 20 years ago we could have foreseen that and like named them something different, but really, like, we've been pretty happy.
You're not the only one to lament that particular choice.
Yeah. And you know, I was able to like being able to cheat and do weird stuff here and there. Like I was able to figure out a lot of stuff very fast. I was actually really impressed with, like, I'd done Linux stuff before. I was impressed with some of the stuff that FreeBSD let me do very quickly with gather type stuff that I don't have the full list of stuff in my head, but just like, if you know what an OS does, like the FreeBSD version of something is usually not very confusing. Sometimes it's a little idiosyncratic, which is fine. That's how you make your own product. But it was very rarely like deeply confusing. And I was very happy for that. Anybody?
Okay, I think, well,
Okay.
I think actually in terms of time, because I need a
Oh yeah, we're gonna run out of time soon, or we've already run out of time.
But thank you very much.
Thank you for having us.
So I'm going to swap laptops, so you can have a couple of minutes to talk about toys, if you wish to, or things.
Yeah, there's kind of random antithesis swag. By all means, I know I told you to keep score. That's only for your own benefit. Feel free to talk to me afterward. I love to talk about this stuff. And thank you again for having us here. And also, thank you for building all this stuff. Like legit, like one of the reasons we're here is like, it feels really nice to just say like, hey, we use your stuff. It's pretty cool. We did cool stuff with it. And, you know, hopefully you feel appreciated. Because we do appreciate you. Thank you so much.
So thank you all for coming. I do have slides, so I'll be misorganized, so I'm going to have to, while I wait to reboot, I'll scatterbrain. I did mention the survey earlier, so in a second, I'll be able to show you the URL, and I'll end with a QR code that should be big enough, even from the back of the room, to work on your phone or other device. So we do have a survey. We would appreciate you filling it out. We're looking forward to having a Dev Summit here next year as well. So keep that in mind. We're always looking for what? No, I have it unplugged from here. It's my laptop. It's not your stuff.
Okay, cool.
No, it's I won't name who is responsible because I don't know. Oh, okay. Oh, that might be why I didn't see it. Oh, that's kind of cute. Dang it, it might have worked because I'd intentionally rebooted on purpose so that it would work. That's okay.
As soon as I heard, I'm like, oh,
Well, you know, sometimes, you know, very bright in certain areas. Anyway, not like we'll pull you off my thought. For next year, we were always looking for various things to help make a summit work, as I'll get to when I get to the end. Some of the things we look for that are very helpful are sponsors. It's always helpful to help subsidize the cost, especially for some of our developers, in terms of, you know, we got to pay for the food and the rooms and so forth. We're also, though, the biggest thing we do every year is finding content. So be thinking about something you might be willing to talk about, or a group discussion you might want to share, similar to how we talked about RE this time, or even Warner's discussion about bylaws. So, you know, thank goodness you did not listen to me talk for 2 days straight, right? That would have been a bug. So content is actually the biggest thing that we need to make Dev Summits work. So keep that in mind. Now I'll try to do this one-handed. One should make, yeah. Usually passwords are not meant for this. Hang on. Almost there. Yep, I'm getting there. Slowly but surely. Yeah, it's almost there. Okay. Okay, now that that interruption is over. So this is kind of the last things we'll run to. So let's start off with, I mentioned that we like sponsors. So let's thank the sponsors we had this year, starting with the FreeBSD Foundation. Thank you to Scale Engine for being our video sponsor and hosting our restreaming services. Is this not, oh, it does, oh, the animation didn't work. Okay, so I got defeated. So we'll get to the ones at the end that you see the whole time. First of all, thank you to our speakers, my lack of doing PowerPoint. So thank you to our speakers for the content that we needed. Thank you to all of you for coming, because as you can see, many of these talks and the sessions are interactive, and so a speaker alone by themselves would be, they wouldn't enjoy it, and it wouldn't have been enjoyable for anyone else either. So thank you for coming and participating. Thank you to Diane for once again stepping in to handle our group photo. Thank you to our live stream team. for keeping us on, for all sorts of people who aren't here to see us. Which reminds me, I guess even we have attendees who weren't physically in the room who also contributed with especially with our 15.0 session and so forth. So thank you all for that. And for all your comments on YouTube and other places. They're appreciated or something. Thank you to our AV folks from Ottawa and the support we get from them. And also to BSDCan. Every year, we get a lot of support from BSDCan. We're not a purely self-contained conference here. We're definitely piggybacking, and same with Euro. So we get a lot of support from our local conference organizers. They give us a lot of help. And then lastly, I'll ruin the surprise. We do have a group of folks who sit and plan out our summits. I know like this year we probably started in January working on this one, and we'll take a few weeks off before we start planning for the Vinda Summit in the fall. So folks like, and I'll kind of not miss them all, Ed and Ann and Deb from the foundation, as well as Lauren. I think, who else? Am I missing anybody? I'm looking at Ed. Yeah. Kind of. All right, I think that's it. Okay, so thank you to all our folks who have helped out. And then here's your survey link. I'll leave this up for a while, so take a picture. Please go fill out the survey and give us any feedback you have. You can email the whole group at devsummit@freebsd.org. And then we'll see each other. We have 2 days of conference left, so don't be shy. We all know each other. Have dinner, yada, yada. Woohoo! See you next year.